this morning, and I hope you had some good beer and wine and little bits to eat last evening here, and you're able to know more of the people attending and make connections. And you continue to collaborate for technical reason or business reason. That's the purpose of this event. One of them to share the knowledge, but the other one is to get you to know each other. I'm just giving you some welcome notes now for the morning to remind a bit of some things, and then I'm gonna pass to Giovanni. So yeah, again, thank you for all our sponsors. First, the host, Fraunhofer Focus, together with the Fraunhofer Forum to get this venue for the conference, and then SIPgate also for the nice t-shirt, but also helping us financially to support the speakers to come to be involved in the project. Many thanks to Twilio as well. Nice presentation yesterday, but also a sponsor of the event. Libon with Federico, Philippe, a lot of contribution to the code, but also supporting us. Banafo and Zoiper with Mira and Joachim. Approach them if you need client-side or speech recognition technology. Client-side application like Zoiper, but you can brand it and can be like a SIPp communicator. And then Simud, unfortunately, Charles couldn't make it. He missed the flight. So with this occasion, we'll have a change in the schedule. We'll move a slot a bit earlier, and probably we'll allocate a bit more time for a dangerous demo, as seems to be a good crowd that wants to show us demos today. Elodie and Fred with a lot of support during the year to the project with many servers and matrix channel, but also supporting the project here. The magic of streaming and video recording, all working smooth as usual, done by the Pascom guys over the corner there, which Sebastian had a nice presentation yesterday. And then Snom with this typical desk phone. I gave away a few yesterday. We still have like 2 devices to give. Probably one will award the dangerous demo participant, our choice, and our partner from FreeSwitch in their conference, ClueCon. I'll have a bit more words later. So this to get started, and very important, as I know many of you bring the bags, try to keep at least the very important things like this, portemonnaie with you, because we are here, but as you notice, the building it's shared with others, and it's hard to keep an eye to see if someone without the badge gets in, and So what's very, very important, don't leave it anywhere, because we cannot take responsibility for it. And the live streaming, if you want to pass it somewhere, it's practically the Kamailio World YouTube channel, the link here. And that would be for today. We're gonna switch now to Giovanni, and a bit later Stefano. They will collaborate on this talk. So I'm sure many of you know Giovanni has been to many real-time communication events, many of Kamailios, but many of ClueCons, for example, at FOSDEM and so on. He used to be a heavy lifting guy for FreeSwitch, now also taps the mobile world and 5G, 4G, and as he's a big fan of is gonna offer. We also give some SNOM device, probably another book to those that have something interested to show.
I think it's...
No, you have to get it out and replug it to now.
Yep.
Can you? Was working? Yeah, you have to start the presentation mode. Giovanni, you should move here. Wait a second. Move here. Okay, so are ready to start. We'll adjust with the next break. If you need a bit more time, then you can.
So it was after a bumpy start. Let's try to begin.
Okay, thanks. You can
Thanks
go.
a lot, Daniel. And so I've changed all my presentations, so I'll be sorry if it's not so much polished. I exchanged some sleep for some slide. And so, because some other presentation was touching about how you can have a lab with 5G, 4G, LTE, etc. And particularly Ramona and James have touched this more, let's say, practical side. So I just not to repeat too many times the same things, I changed mine, and it will be more about why you want to do that. Because, okay, we're all talking about that, but it has to be a meaning somewhere. This from one side. From the other side, I also cut my time, and you will get the rest of the presentation from the slides. And I will make space and time for my friend Stefano, that he will speak about what is the future of IMS. IMS is the application that run on top of 5G and probably 6G. So without much further ado, I'll begin, then I will leave for the future. Okay, this is about me, and you will see in the slides. And so 4G, 5G, and probably 6G, what it is that is only another Ethernet. Is only something that gives you TCP/IP connectivity. It has nothing to do with the real-time communication. It has nothing to do with our things. In itself, a 5G network will just give you internet connectivity, TCP/IP connectivity, and nothing else. Apart from there is a lot of features that then we will use, but is not in itself connected in any way with audio-video communications. So 5G, we can think at super-duper Wi-Fi. It will be the mainstay of all kind of infrastructure, particularly into office buildings, on the factory floor, you know, to exchange data in real time between robots, controllers, etc. And for all IoT deployments. So sensors, all those kind of things. Why that? Fundamentally, because you have really fast and really responsive network with a good bandwidth. Also, another important thing of 5G is that you can manage, and we will see how we interact with that, you can manage a lot the quality of service. So, bandwidth, response time, delay, all that with priorities. So, it's like we now and then try to have with the VLAN, with controlling the switches, etc. This is at the lowest possible level, is at the radio level, at the transport level. So it really works. The prioritization of each kind of transport or traffic. Both fixed and mobile carriers internally use IMS, and we will see what is IMS, is a super duper SIPp. And smartphones are what we all and also the other people use to interact with the network. Desk phones, our workhorse of voice over IP, will be another form factor of a smartphone. Inside, they will have the same operating system and the same capabilities of smartphones. Obviously, you want to have the handset and nice keypad, but inside there will be smartphones. The important thing is that the market is going to change. So carriers, CLEC, MVNOs, whatever, the big guys will expand their offer. And they will try to hit our lunch too. Just because they have a lot of people and a lot of marketing, and they will not limit themselves just to voice call to your grandma and SMS. This is going to change. They will expand on the lower side their offerings. So why we all are moving or begin to think about how to move our things in the direction of 5G and IMS, that is the application level that runs on 5G. Because we want to be relevant, we want to stay on the market, we want to continue our business. And what we see as the three big markets that are opening and that are beginning to come into existence with the help of 5G transition. So for us, I mean, it will be supplemental services that we can give to carriers and MNOs with an agreement like, okay, we will build this special community communication server that is targeted to this specific niche that for you carrier. And all the private networks, all those networks that are pure data networks in the office complexes, in universities, in enterprises, etc., then we can offer voice and real-time communication on top of their network. So more or less the same that we do now with their Ethernet network. Then another market that is, I think, is very promising And I would like to have your feedback on that after in the question and answer, is RCS. RCS is the instant messaging, let's call it that, in IMS. Actually, is much more powerful and very complex and with a lot of features that is actually, let's say, a unified communication plus, third 3.0, etc., inside IMS. And they are starting to push it a lot. Why is interesting for us? Is interesting because it's totally integrated into the smartphone. Actually, when you exchange SMS, you are actually exchanging RCS on the back. So we all have an RCS client in the smartphone that actually is capable of doing so many much more things. It's just that they are not yet exposing it, but they are already capable. I mean, you can do things right now that appear into the messaging client of that you think is SMS. And so that also will be, I think, a big market, but for, you can think about what can be a very rich environment for instant communication, but at the level of inside one organization and into exchanges between the organizations and customers or users in the case of public administration. So what we need? We need to bring our services or our future services, our competence, our capabilities that we developed in the years at the level of SIPp, we need to bring those things at the level of IMS. IMS is like a SIPp++. There are many things like more headers, more security, this, that, and that, but at the end of the day, it's kind of SIPp. So we totally understand it when we use it to deliver a service. But what we need is the ability to first deliver the service, but access that service and check and see how it works. For sure, it will be possible because, carriers will open the market to give our services as a plain SIPp, so not IMS, through the carrier or through the provider that will open a SIPp connection to us. But it will be not nice, they will not like it, it will be, the sad cousin of real things. We don't want that, we want to be the top of our class. So we wanted to integrate with the carrier, with their profiling system, etc. To do that, we need to check and to test our things, and the only possible way, the only one, is to use real smartphone. The problem is there is not, and probably will not exist, an IMS client that you can use outside, that is not a smartphone that connects through the radio. So the only way to do that is to be a mobile carrier, be your own mobile carrier. You need to have a tower with the radio, okay, a small tower, a little one, and you need all the rest of the stuff. And because you need to use smartphones, there is no other way. And so we will use the little radios, the open source software, etc., to do exactly that. Now I stop because it's time for Stefano. He will give you. I spoke about the present, the current situation. We have a little bit more time. About the current situation, Stefano will speak about the future of IMS, because there is much more interesting things that are coming into IMS. And please. And I mean, all the other slides you will find when they are downloadable, probably.
Oh yes. Okay, let's see if I can have this. How can I? Okay, I'm gonna make this one. So I'm gonna make this one working. Okay, it doesn't work at all. Nice. Okay. Towards 5G and above IMS. So, okay, you already got the answer. The answer is IMS. But the problem is, from my point of view, is what is the question? Which is the question that the IMS is answering to? First of all, who I am. My name is Stefano Bertuola. I work for Atonet. Atonet is a company that make 4G and 5G course, and also we try to play a little bit with IMS. I am a telco guy for almost 25 years. I am a telco addicted guy. It took me between 5 and 10 years to become a telco addicted, because it takes time. It's very complicated, the telco, to understand it. But then I'm also acting a telco evangelist. Maybe some of you met me, and so I'm promoting telco, because I have this mindset. I'm not very good in coding, especially C, C++. I really would like to contribute to Kamailio, but I cannot code in C, C++. It's not my... Okay, in the telco, they did many jobs, starting from implementation, plugging cables, blah, 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 blah. And today I'm trainer in 4G, 5G, and IMS. This is what I do. Before to answer the question, to provide the answer, IMS is the answer. We need to rephrase the question. So let's talk a little bit about the telco. My presentation is going to be quick and dirty. I have 15 minutes. I need to check the time over there. Okay, 15 minutes. It needs to be quick and dirty. So I need to just point out, the evolution, how it has been the evolution of the mobile network. And where we are today, we are 4G, mainly 4G. So the mobile network is mainly, just got my phone. And the mindset of the people thinking about mobile network is this stuff here, mobile devices. And to provide connectivity to mobile devices. With the 5G, we are completely changing the paradigm. Also, something else happened in the market that it was outside the 3GPP or the telco guys. And one marking point is it been 2007. 2007 is the year that they introduced the iPhone. The iPhone has been introduced, and the market completely changed at that moment. We moved for these kind of devices to smartphones. And also the demand for the operators, for the network, for the mobile network completely changed. What happened with the 5G? What's happening in 5G? We're going to show you. But just last days, and I showed there this picture here. So are we going to have a new market changer? So there was this competition between Apple's and Meta that they are starting to push hard for this Oculus, this virtual reality, the mixed reality, extended reality stuff. So we had this announcement there. They were competing these two guys. So in Apple and Meta on the other side, says, hey, we have this the Oculus coming, and so on and so forth. So it's going to be a new market disruption there with this new virtual reality coming and the need to support for this kind of services. We don't know, but something else is going to change. Something else is going to change. Okay, and I need to move back to my presentation. So here. Okay. ITU Vision. ITU Vision is, what is ITU? It's International Telecommunication Union. It's the oldest agency in United Nations. So how the telecommunication evolves, it comes from United Nations. And the people that they are there represented in different countries, Europe, Asia, America, China, India, Korea. Okay, and this is the picture that they made. So when we are thinking about, okay, this is the use case. This is the use case. We are just looking at this point here. Here, mobile broadband. But we don't see all the rest of the picture. There is a huge rest of the picture, really. So 5G is enabling, we are going to see just some use cases. This 3D video, ultra high definition screen for this Oculus stuff is enabling augmented reality, industry automation. This is something that I'm going to talk about. Self-driving cars, they are pushing hard for self-driving cars. They have a big issue in the US after the pandemic. They are not able to find people driving trucks. So they don't know how to move the stuff inside the country. So they are pushing hard to get it, these autonomous driving cars. But it's not just stopping here. It's not just stopping here. It's also they're putting other stuff in the pictures, and they are also putting other use cases, because in the beginning release 15, 16, they just focus on this corner, on this corner, on this corner, but then they find out, like our lovely smartphones, that they are somewhere in the middle. So they introduced this Red Hat reduced capacity, and this stuff is targeting other kind of devices, like cameras, smartwatch, and these other kind of devices that they don't require to have a gigabit per second kind of throughput. I'm going to show you a video. This stuff has been announced. I mean, the 3GPP specification are released from time to time, more than 1 year. So the release 17 has been released April last year. And a few weeks ago, February actually, 2023, for example, Snapdragon announced the first chipset that is going to use for that. So they just announced it. So just about to show the video, I just want to stop it. Because I was looking for the specification of this stuff, and I wanted to show how big is this, this thing here. This is what I wanted to stop. Where is my mouse? There. I wanted to stop here. Okay, I need to go a little bit back. Okay. They announced that this chip is going to be available middle of this year, mass production next year. But the target of this chip is to have a modern in-size phones, glasses, so small places. This is the target of these kind of chips. Okay. So yeah, just to see how is the scenario is evolving and which kind of use cases that come in the scenario. I want just to say one thing is in a mobile network, to have a service, it needs to be supported by the whole mobile network. The service needs to be natively supported by the chipset in the device, natively supported, not by over-the-top application, but the chipset of the device, by the G-Node-B, by the core, or something that is attached to the core that is providing the service for that device. But the most important thing is the chipset is not a software, over-the-top application software that is running over the phone that enables it, okay? So, okay, I'm gonna skip it. So this is a pictures like, what is I took it from Nokia. So is different use cases, the phones. cameras, virtual reality, augmented reality, autonomous driving stuff, real-time communication for the internet industry 4.0, etc., etc., etc. And the question is, where is IMS fitting here? I'm telling you, almost everywhere. I'm telling you, almost everywhere. So the big question is how to allocate the dedicated resources with the proper characteristic, quality of service for a specific application. And the answer is, you know, but okay, let's put some kind of, I need to talk about, before to provide the answer, I need to talk about quality of service. 3 pillars of mobile telecommunications: quality of service, security, resiliency. And to have quality of service, when you establish the connection like internet, you get what is called the default bearer or the default flow. And this default flow is providing best effort kind of traffic. But if you want to have dedicated flows that is taking care of a specific traffic with a specific quality of service for a specific application, then you need the device communicate with something in the network in order to request to the network, to the 5G core, to establish that a specific resource is there. And otherwise, we cannot gonna get it. So let's have just a quick look about what is, okay, the quality of service is a big topic, but I want just to tell you that we have, first of all, we have a class. No, first of all, we have a class. So every flow is characterized, so every packet that is handled by the 5G network is going to be classified with a quality of service profile, and one of the parameters is the class. So we have 3 classes. No guarantee bit rate. So the guarantee bit rate is 0. And this is important. All the connections that you make, the first connection is non-guarantee bit rate. Okay? Everyone that is using 5G, they use 9, maybe 8 or 6. Is not guarantee bit rate, very low priority in packet scheduling on the radio interface, 300 millisecond delay. So these people, they are surprised, say, oh, I make a ping, it's 5G, they promise me a few milliseconds, 300 milliseconds, why? You're using this kind of class. And this class is made for generic best effort internet kind of connectivity. YouTube, buffer streaming, TCP, email. So if you want to have a better quality, you need to go to other classes. And these classes, they cannot be established in the first PDU session. They need to be established as a dedicated flows via someone. And here we see that we start to have the guarantee bit rate, audio, video, mission critical stuff. And the new ones that came in 5G, live uplink streaming. Live uplink streaming, that is very important, the cameras. So you can see that you have a certain delay. 150 milliseconds is the maximum delay that you can get in a video for your mind not perceiving that there is a delay, 150 milliseconds. The Apple, they promise that the Oculus, they're going to provide the image in 12 milliseconds. Okay. But here you also change, we need to also show you, I'm going to show you another change of paradigm. We also think about, Wi-Fi replacement. Download is the most important one. No, or maybe not. In some cases, the upload is the most important one. When you have Internet of Things, is the upload the important one? Is the device sending data to the network? Is the camera sending streaming to the network? So just also when you talk about this kind of stuff, just throw out the idea that download is important, is the most important part. No. Or at least you need to check your use case to see how you need to balance the resources from downlink and uplink in order to have the proper resource allocation and the proper bandwidth in order to serve your use cases. Okay. And now we are getting to this delay critical guarantee bit rate. So we start to see the low delay, 10 milliseconds. I'm not going to get too much in the details, but you see motion tracking data. But for example, for Industry 4.0, this is the one, discrete automation. The Industry 4.0, what is asking? I need to have to replace the wired connectivity for my PLCs from this equipment that are coming from the 70s or the 80s with wireless, but having the same quality as a wire. So we need to have a 10 millisecond, okay? So the question is, okay, so the IMS, evolving IMS is the answer. So this one you can get with the default connection. These ones, you need to have someone to communicate with, to instruct, to ask, in order to get this kind of quality of services. And the answer is IMS. I'm going to show you one example. I need to put glasses, my gosh. Getting 50 years older, and someone needs to tell me how much time I still have. Okay.
Like 3 minutes, it's okay?
I can tell, okay, speak for more 1 hour. No, but
you can do a dangerous demo.
No, it's, I'm going to say you, just going to very quickly, sorry, with the mouse. Okay, uplink streaming. So what is this uplink streaming? Is a camera needs to connect and to request. So I need to request the resources. So the device inside the camera is going to have, which is the answer, I'm going straight to the answer. The answer is IMS. So the camera is going to have an IMS client side, is going to send an IMS request in order to establish the default for this kind of stuff. What about the future? What about the future? Okay, and here I need to go, please give me 2 minutes more. And I'm going to show you, and because here is the, okay. That's zoom it, okay. So we are in release 17. Okay. Release 18, coming April next year, maybe. And they have a focus, evolution of IMS multimedia telephony services. And what is this evolution for? So they are working hard to increase the capacity of IMS. They are working hard on that. And we are going to have a look what does it mean, this increase of the capacity for, oh my gosh. Do we have it? Yes. Okay. Where is my mouse? Okay, here. Go down. Quickly. So here. So the challenges. So we need to have the possibility to establish a request, to make a request, not just for video, not just for data, not just for streaming, but for data as well. So we need to have the possibility to establish data channel with IMS, okay? Augmented reality telephonic communication and study for something else. So the IMS is going to be the 3GPP answer to allocate all kind of resources, including all the kind of the devices that they need to have a dedicated flow to carry data. And this is one of the picture, and I'm going to quickly to the hand. You can have more, this is a study. I mean, this is what they are studying, the solution data channel architecture. So this is for IMS. So data channel. I'm going to go back quickly to my presentation and just to finalize it. Okay, just a second. Just give me 1 minute more. Okay. Okay, legitimate objection. Hey, it's more than 10 years that someone is coming here talking about IMS. Why is still bothering us? It didn't succeed in the last 10 years. So why should be different now? Some facts. The market is changing. Okay, first of all, there's been in the last 10 years a really big resistance from the operators to move to IMS. I heard that the US moved quickly, but the Europeans, they didn't. Now the Europeans, they are moving to IMS because they need to switch off the 3G in order to make electromagnetic space to implement the 5G, okay? This is one of the reasons. Italy, they already did it, Germany already did it. IMS, is the recommended solution for allocating resources. The other one, private network. Private network is becoming more and more popular, and frequencies are going to be liberalized, are going to be available in countries to deploy private network, you know that to deal with the legacy operators is a nightmare. So everyone is expected to have the possibility to rent a license and to have its own private network and to deploy a 5G core as we saw. And to be private network is IP-based, so you need IMS to provide even the basic voice services. News, iOS 17 announced 2 days ago. And this is for Ramon, I don't know if he's here. I just got last night the firmware. And the iPhone with the iOS 17 is supporting the CBRS, that is the private network with 5G, for 5G standalone, and all PLMN starting with 999. Okay, so you have iPhones in US at least, and probably in they're going to be able to work in 5G standalone. And just the last picture to see now which are the countries that they have a private frequency, which are the countries that they are moving to get a private frequency. And I'm expecting the next 2, 5, 10 years that more and more countries, I hope also Italy, they're going to be part of this group of people where you can buy a license and you can build your own private network. Sorry.
Okay.
Thank you.
Thank you, actually, Stefano. That was actually great for knowing where the market goes, because sometimes as a developer you don't have this larger view of standardization and push of business and other vendors, what they do. Okay, 1 or 2 questions quickly. And Frank, can you come in front to prepare?
Yeah, I have a question. What make you think that the big vendors like Apple, Meta, and whatever will actually do some stuff with the operators, and they not just accept, let's say, this low quality, let's say, existing generic network as a fact, and then just put their own technologies over the top of it to provide the seamless streaming, like we have seen, for example, with Google. Maybe that's not super good example like Stadia, but NVIDIA Shield, like with a playing remote play from PlayStation. So they just don't want to dive into this swamp, and they will just accept the existing networks and as reality, and will just do their stuff on their own, like they did, for example, with the channels, like building their own CDNs and so on and so forth.
I need to tell you, the operator is slow to move, and they're driving by Apple is one of the main players driving. The fact that Apple open up the CBRS PLMN, so all the private network US now they can use the iPhone, is a really change. Is a really big change, as it has been the iPhone in 2007. So the operators, you know, this Apple and Samsung, we need to look at closely, and the Qualcomm look at closely, and Quectel look at closely to see what they are doing, because these are the one driving the market. So what is going to happen? I don't know what's going to happen in the future. I know that still there are operators and people try to avoid IMS as much as they can to avoid IMS. So, but it's going to happen that they're going to be forced to go there. We are going to be forced to go there. So there is no other, they are going to try to make some workarounds, dirty workarounds, as they did in the past. It's going to work also in the future, I don't know, but.
Okay, thank you, Stefano. Probably you should address him privately in the breaks, because we don't want to delay that much. We started late, so we'll adjust with the coffee break, but thank you, Giovanni. presenting. You
Okay,
can-
you don't
go
have to
ahead.
worry. It's not going to be in German. Just the template didn't allow me to change the first slide. This is going to be secure access to legacy PBX systems behind net using Kamailio and RTP engine. Is that also you back there? Is it better now? Okay, not touching anything. Okay, my name is Frank Gorgas-Waller. I live in Germany. I stayed 10 years in the States. I am active with VoIP since about 2000, which I think is a while. I first was active in Asterix, and I started to experiment with SIPp pretty early as well. But most of my career, I spent a lot of time with Asterix. For the last 4.5 years, I am working at VoLTE, a German manufacturer of telephones and PBX systems, and we were put up to the task to connect soft phones to our PBX systems, which was not that easy because our SIPp stack is about 15 years old. There was not very much done on it because people always decided that refactoring was not that important. It was originally basically designed just to talk to itself. We have the same SIPp stack in our old telephones and in our PBX systems, and it worked perfectly fine when you have the same protocol and the same interpretation of RFCs working on both sides. Everything is fine. It was never really meant to support any internal devices on the internet. We actually have two SIPp stacks in the PBX systems now, one for internal and one for external. And so the internal side never ever was meant to really work with the with anything from outside. It has no options for proxies for internal phones or anything like that. It only allows the use of local IPs, not domain names or anything useful. RTP code is using a library that is not maintained anymore, and we have our whole RTP stack in a separate module that tends to crash once in a while when you send it some wrong packages. Not very ideal to hook it up to the internet. So nothing could go wrong. The SIPp clients, however, will not be in the local network because we wanted to actually have SIPp clients that would be able to also like be used on a mobile phone or something like that, which usually do not always connect to the local network. It should work from anywhere, basically, and since you're working from anywhere, it could be IP4 or IP6, and yeah, those soft phones we decided to use needed to be provisioned from a central domain as well. I know people here might know SIPr. There are some people here as well. And yeah, we used basically SIPr as a quick fix to quickly implement that project. Yeah, the credentials should, however, not be stored on our servers. We like them to stay on the PBX systems on site, on the customer side. We do not want to have like a big pool of credentials that somebody can break into and grab credentials for like 15,000 phone systems or something like that. That would be not good in the press. Even so, some people say every press is good press, but I'm not sure about that. So what could go wrong? The setup. One of the problems that we really had to anticipate was not only the technical problems with the implementation, but also the problems with the implementing of the software at the customer side. Most of our systems are used by small businesses, lawyers, doctors, stuff like that. They usually have a highly trained, available IT staff on site. Oh, no, they don't. They usually have no IT experience whatsoever. But we have a network of resellers that actually is the only way how you can buy an Hours Vault PBX is by going to one of our resellers or by grabbing it on Amazon or something like that, which is actually more expensive than going to a reseller because you need an activation code. Most people don't tell you beforehand. Those people are not necessarily always as skilled either because a lot of them are electricians or a lot of them are just people that just resell stuff that in that stuff doesn't necessarily have to have anything to do with telecommunication. Some of them are really great and knowledgeable, but not everybody. So it should be easy to deploy. It shouldn't need any local setup, port forwardings or something like that, because that has been proven to be very error prone. And so basically it has to be foolproof. Still, nothing can go wrong. A local client within the PBX connecting to the proxy over the internet. Yes, that's what we came up with. It's a proxy. No, it's not Kamailio. We have a proxy within the PBX. So it talks to the inside of our internal SIPp stack, and on the outside, it actually talks to Kamailio. There is no port forwarding needed. The telephones appear to be local. Authentication can be done against the PBX. And the client can also forward other requests like provisioning requests. That was an important feature since we are using those soft phones that want to be provisioned. So on the outside, now is the interesting part. We have a bunch of servers which actually have a Kamailio on there. And the SIPp clients within the PBX are forwarding their traffic to the servers with a Kamailio. And whenever a PBX system registers with one of those proxies, they actually get a private DNS record, like a DIM DNS record, but not pointing to the PBX. It's pointing to the server that they just actually registered with. So we have multiple servers. These servers are interconnected, but each one of them can work perfectly autonomously. If a customer wants to operate their own server, technically they could. You can put the name of the server you want to use into the PBX, and it'll use that server if it can do whatever needs to be done. Each PBX has its own subdomain, and the provisioning of the phones is done via HTTPS. So the provisioning of the phones is going to those servers, and they are actually available all with one name as well for the provisioning. And with the credentials of the telephone that the user gets to set up the telephone, the web server actually can find out which PBX that is supposed to be. Yes. And we're basically taking that HTTP request and putting it into a SIPp package and sending that SIPp package through the established SIPp connection between Kamailio and the PBX and sending it to that PBX client in the PBX, where actually it finds out, oh, this is a special info package. It looks like somebody is wanting to send some HTTP through there. Let's unfold that and get my stuff out. So the whole setup in total looks about like that. We have in the, is that, okay. We have the PBX, and in the PBX we have the legacy PBX core. We have the proxy client, which does the communication to the Kamailio, and we have the HTTPS provisioning in the PBX. And we have the legacy RTP engine, and we have the legacy RTP in the PBX, and we have RTP engine in our proxy setup. And so whatever goes through here has like more or less clean RTP coming from RTP engine. And the Kamailio here is actually cleaning up the connection as well. Okay. Now, when the mobile or desktop client soft phones connect, they connect to the proxy, and all the communication goes from the client through Kamailio to the internal proxy to actually the old SIPp core. Now, here's a small example. This is what the register process looks. So we're actually having a name, a proxy.ourproxy.de, which is referring to a group of proxies. They'll get a random proxy of those back, and then they send a register there. They'll get an OK back. At the same time, the proxy actually registers the name for the PBX in the DNS, and the soft client then can query that name, because that's what in his what he has in his configuration is the name that actually points to the specific name for that PBX, and he will get returned the proxy server that he has to communicate with. The same thing works equally well when you just connect to any other server. You get the servers assigned randomly. Okay, now a little bit more complicated here, provisioning. The client will request the DNS name for the provisioning, which is profdata.ourproxy.de. He will get a proxy back, which again could be any proxy. He'll send an HTTPS request. That HTTP request will give him actually a query for the right proxy, where he can get with HTTPS the information he needs, which is then going to put into SIPp packages. The little loop here is there is a separate process that is actually translating these SIPp and HTTP, which is an FCGI program within the proxy. And then it's sending a SIPp info message to the PBX. There is that small proxy client in the PBX, which takes that out as well, connects to the web server in the PBX, and then gets data back from the web server in the PBX. And then, since that data not necessarily fits in one package, we actually sent a bunch of 183 messages. That is maybe not the most clever way to do it, but it was quite easy when we did it at first. The configuration for the phones usually are like a K or something like that. So we expected something like 2 or 3 messages going through there. So you see here on this example, you have like 2 or 3 messages. Okay, as soon as all of those messages arrived at the proxy server, the proxy server is actually going to assemble them when it gets a 200 OK. The 200 OK actually has a checksum in there to verify if everything was received correctly. And when everything was received correctly, it'll just send the message back to the client, and so the client gets its provisioning information. Sounds easy, or? Now, let's see. This is a picture of how the process works in parts. This is like from the our proxy client. It registers at the our proxy. The our proxy creates the DNS name. The DNS name is queried by the client, and it does a SIPp register. The SIPp register is forwarded to the proxy client, which forwards the registration to the PBX. So the PBX thinks there is just a regular internal phone registered and doesn't know anything about whatever happens in between here. Whenever a call is established, the call is placed from the caller to the hour proxy, which sends the invite to the proxy client, which goes to the PBX, and so forth and back. So what did we use Kamailio for? Actually, most things, but not everything. Kamailio does SIPp rate limiting. We don't want people to completely kill the system by sending like thousands of requests or something like that. We don't want to have just anybody access the system and maybe connecting to a customer PBX that is not supposed to. So we're doing some sanity checks before we even forwarding anything. Like filtering for allowed user agents. There's only certain user agents we allow. There is a connection to the push proxy that we maintain. We provide logs for fail to ban. We actually did a separate logging just so that we can have very short log files that will only have like known goods and known bads in there. And on those known goods and known bads, we have fail to ban rules that actually will ban offending people relatively quickly. We actually have different categories for those ban rules. So we know if something is like a definitely very suspicious or attacker-like pattern, they'll get flagged differently than if something is like some user configured their phone faulty and has a wrong password in there. You don't want somebody that configured one phone with a wrong password to block an IP that maybe a whole company is after. That's not a good idea. We want to avoid that, so we have different categories. But if somebody is actually running an attack or something like that, you want to make sure they're basically blocked right away. Yes, since we're using RTP engine, Kamailio has to control RTP engine as well. And there is some limit for the HTTP forwarding that we're doing also in Kamailio as well. Conclusion, Kamailio was a good choice because it is working nicely. We don't have any complaints about anything what has to do with Kamailio or so. The load on the servers is mostly negligible. There's very little. We don't have to worry a lot. The availability is great. We have like a close to 100% uptime. Basically, the only time we don't have uptime is when we have a scheduled reboot of the system for OS maintenance and stuff like that. Dan as a service. Yes, we use Daniel as a service for 3 days during development, which was nice because we were thinking we had completely screwed up on some things, and we were actually able to find out, oh, actually we found 2 bugs, which Daniel was nice enough to fix. And yes, we did some things that could be done better, which Daniel gave us a great help and showed us what can be improved. Now, if something works that great, the obvious thing that was bound to happen was people found out, okay, if we can use the proxy server to actually access provisioning files, can we maybe access the REST API on our PBX systems as well? It's basically nothing else but HTTP access. Yes, basically it is. So we actually extended the service so we can not only allow access to provisioning, but we also can allow the newly created context control center, which allows resellers to manage all of their customers' PBX systems to actually use the same connection to access a phone system from the outside without having to have a dedicated VPN to each customer or something like that. It will only connect to the phone system itself. There is no access from there to the network or anything like that. You can just use it to use the API, control API on the PBX system. For that, we actually had to extend the tunneling protocol to allow a few more HTTP methods. And we had to change some of the filtering, so we not only allow provisioning data, but also access to the REST API. Future plans, yes, there is more to come. We want to provision other phones, not just the phones that we currently do. We currently are working on provisioning our own desk phones as well, so they can be easier configured for home office and stuff like that. Our D-series phones actually allow, they have a built-in OpenVPN, and this way they can actually be configured and actually provisioned completely on the outside. For that, we actually decided to do a little bit of a upgrade on the tunneling, because the configuration files for those phones actually can be substantially bigger. Our phones support like programmable function keys, not like many of the other function keys I know of. Our phones actually allow that you can put Lua code in the config file, so you can write a whole like long program doing some web access, getting information, switching stuff on the internet and things like that, and put it on one of our function keys on a telephone. Whatever you can do with the functions we have in there, you can put in there, and it all goes into the config file. So the config files can be quite a little bit bigger. Yes, and we want to put WebRTC on the RProxy as well. So people can actually have a option to have a WebRTC client on the RProxy as well to connect their telephone system from the outside, or to maybe put it on a web page or something like that. So this was it, basically.
Thank you.
I am available for questions, if they're
Okay.
not too complicated.
Oh, I mean, you did a lot of coding behind this, as I could
Yes, I
figure
did.
out myself. So why not difficult questions here, right?
Okay, you can ask difficult questions as well.
Okay, questions for Frank, who here?
It looks a bit strange when you use 143 for send some data. Did you check the MSRP for this?
No, we did not at the time.
Yeah, MSRP, it's another technology that was a hype around, you know, this protocol that is supposed to be used for sessions, but chatting, texting between, like you make a call, but not for audio video, but only for, or you can combine it, but the MSRP is for like text channel.
We actually currently already established a protocol. We're using a data channel. We're establishing a data channel in STP. Yes,
Nice.
the code was finished like 2 days ago.
That's very nice. Okay, if you need to talk with Frank, because we started a bit delayed, but we don't want to push it that much into the coffee break, please approach him, because it's really technical. He did cool stuff. If you want to discuss about MSRP, approach me, because I wrote the module for Kamailio, but it's very, I mean, like no usage from my point of view lately, from maybe a few deployments in the past. Frank, really appreciating your presentation and presence here.
Yeah, just a quick overview about my talk. I will tell you a little bit about me. I will try to limit the advertisement to a minimum. I will talk a bit why we are doing WebRTC at sea, because there's an actual ship that was finished this May, I think, is available now, and will be used for autonomous and remote navigation in the region of Kiel. But I talk a bit about WebRTC video and the challenging network conditions. I unfortunately do have a little bit of overlap of what Tim was presenting yesterday, but we have a little different solution, which I will explain a bit. And then in the end, I will show a tiny demo, which is not really dangerous unless the internet craps out. So my name is Klaus-Peter Junghanns, or just KP, as I'm known by many. I also have some more first names, but that's out of scope. I've been doing real-time communications for 20 plus years. I originally started with Asterisk. Maybe you remember the KPI ISDN channel for it and all kinds of stuff. And fortunately, in around 2011, when Google released the WebRTC project, we kind of refocused on something new, because 10 years of SIPp and ISDN was kind of getting boring a bit. So I got into WebRTC and was the first one to present a public demo of SIPp Interworking Gateway in 2012. We still have a product like this, but we suck at marketing, so you probably don't know about it, but that's fine. To make this work, we have our own implementation of WebRTC from the network layer up into all the audio layers, including audio mixing. We do not touch video, we just transparently transport video in our stack. And it's based on libsrtp, Sophia SIPp for SIPp interworking, and some other interesting projects in there. And we figured out in the first years with WebRTC and video, it's kind of hard to make any money, because at that time, pre-pandemic, nobody wanted to pay for video conferencing, whatever. Even Google figured that out at some point and then started charging money for it. But unfortunately, we came out of the voice over IP contact center world. So we had an Asterisk-based contact center solution, which we had been running since 2004. And we kind of rebuilt this to just be a WebRTC video and audio contact center solution. We have native SDKs for Android and iOS. And if you have ever opened a bank account with a major German bank during the last 6-7 years, you probably made a video call over our platform. But yeah. So what is Captain? That's a nice or not so nice acronym, depends on how you look at it. It's for Clean Autonomous Public Transport Network. It's a regional innovation network based in Kiel in Schleswig-Holstein at the Baltic Sea in northern Germany. And it's has been going on for a couple of years now, will be going on for a couple of years. There will be following projects. It's state-funded, a collection of state-funded projects, and it's done by a consortium of universities like Fachhochschule in Kiel and Christian Albrechts Universität in Kiel, and industry partners. And part of this innovation network, one project, is the MS WaveLab. It's a 20-meter fully electric catamaran, which is now actually existing, and this is not a CGI, it floats, it drives. And we are starting to kind of get access to the systems. So just this week it has been, I don't know what's in English, Übergabe from the construction company to the company that will be operating it. And in Kiel, there is an area which is owned by the military in the water, and we will be using this as a test field. It's a marine arsenal in Kiel. Kiel itself is kind of, the city is split by the Kiel fjord, and the idea was to build a ferry which will travel from one side of the fjord to the other side, because this just takes a couple of minutes. And if you want to go by car or public transport to the other side, you need 30 to 40 minutes. So the idea was to build an autonomous ferry, which will just bring, for example, students from the universities which have locations at different sites back and forth. And for this, we have this ship. It has a lot of sensors on it. It has a lot of cameras. I'll get to that in detail a bit later. And what my job is, I kind of in charge of bringing video from the ship to the shore. A little background on WebRTC video is here, but probably Tim covered this in greater detail yesterday. So what we found out, it's WebRTC video is intended more for stationary use to kind of work around some quirks of your Wi-Fi, or when your uplink is congested a little bit and then it recovers. So they do a lot of stuff to figure out what is the possible bitrate you can run through it with the video bitrate estimation or remote bandwidth estimation. There is numerous RTP extensions or other ideas to do it. There's a lot of experiments going on. And what we realized, especially in the beginning, is it reacts very, very sensitively, so that in many cases you get a quality which is worse than what could be achieved through it. And yeah, we come from a different project as well, where we already were providing onboard cameras on sailing boats, which is used by the German Sailing Bundesliga, and was also used in the Sailing World Championship in 2018. So basically we developed an Android and iOS camera app, which uses a good camera in, at that point, iPhone 6s, but it has improved a lot more by then. And there we learned a lot how this bitrate estimation works. Also, our customer had an unfortunate court case by a competitor which involved WebRTC, and this bitrate estimation was kind of the key. Our customer fortunately won the court case and the competitor lost it. But in that time, I learned a lot of the inner workings of libWebRTC, so the Chromium stack of WebRTC, a lot more than I actually wanted to. And we found out that the solution to work with this bitrate estimation is what Tim also said, just lie to Chrome. And we are doing this in RTCP sender and receiver reports, and then we can just pretend no packet loss, everything is fine, keep sending the video at the requested bitrate. This works fine until you really have network problems. So when you're changing networks, base stations, or when you're coming into the shadow of some object, and then you don't have 4G or 5G anymore for a second or half a second, then things get stuck. And because we were lying about it, the client, of course, keeps sending and the pipe gets stuck. And to solve this, we had the idea, yeah, why don't we just use multiple networks? Different providers at different location, even different technologies, can be 4G, 5G, or Starlink. In some cases, it can also be Wi-Fi. And that sounds like a good idea. And then when you get to implementing it, you're wondering, but how do we do this actually? You could just go the old school Linux kernel bonding device way and just put it into one bonding device and then hope for the best. But the networks have very different characteristics, different round trip times, bandwidth capacity, and yeah, it's you can experiment with it, but you probably won't be very happy because it's just a generic way of bonding the uplinks. It's not aware of that you're trying to transmit real-time video or anything. So yeah, we're not doing that. I also looked at different options. There was a quick multipass proposal which has been accepted by the working group for Quick recently. And I also looked into this, but Quick is not so easy to implement if you want to implement it yourself. Our partners from the universities are using Quick to measure some network quality and latency because they are building some artificial AI stuff which should predict the available bandwidth depending on the GPS location and previous experience and so on. But for us, they seemed a little bit too complicated. I like simple stuff, as you see in my slide design. So I remembered hard disks and came up, which we internally call redundant array of independent links, or RAIL. And we basically just take every UDP packet, doesn't matter what it is, can be STUN, ICE, DTLS, SRTP, and we put a little header in front of it. I think currently it's 8 to 12 octets. It's basically sequence numbers and some identifiers. And then we send that packet over every uplink we have, the same packet. And on the other side, we're in the cloud. We have a system which receives the packet and looks at it. Have I seen this sequence number? Is it in my window? If I've seen it already, throw it away. Otherwise, unpack it and feed it into our WebRTC media engine, what we implemented ourselves. You probably could get away with doing it a bit simpler, because if you use SRTP, you don't really have to worry about duplicate packets. You get a lot of warnings maybe, but if you want to build something fast and cheap, you can also just send the same SRTP packet into your media core. But yeah, we wanted to do it a tiny bit better. So we're also using this to measure the round trip times on all the transports, like every 4G uplink to the cloud, 5G and Starlink. And we are kind of in an early stage with this. So I'm not going to show you something like this working today. It's ongoing research. But at some point, maybe next year, definitely next year, because we need it sooner than that, we'll have something like this to demonstrate, where you can then just unplug one network link completely and you'll see the video is still going on. We're doing a little bit of bandwidth or bitrate management by having one small stream and one big stream. This is currently, it's not scalable video coding, but at some point we want to use SVC for that. But just a second. We have the situation that cameras on board are not selected by people who like real-time stuff or know what real-time stuff is. So they just put it into the requirements for a tender offer. Oh, we need cameras on a boat with preferably IP. And then you end up with all sorts of cameras which are kind of usually used for surveillance purposes. So you have your Axis cameras, or if you wanted a bit more affordable, some Reolink. And usually you can get an RTSP stream out of it. And there is some nice open source software written in Go, which can, using this Peon WebRTC stuff, which can turn this RTSP stream into a WebRTC stream. It does not touch the video codec, so it's just kind of doing DTLS SRTP and probably arranging the H.264 stream in it a bit differently. Has the downside, you cannot change the bitrate at all, not dynamically, not statically. But fortunately, those cameras with RTSP usually allow you to get a very small quality stream and a full quality stream. So we can get those two streams and then we can decide which one we want to send. We also explored other options, like on an Android device, receiving the RTSP stream and then re-encoding it as WebRTC with VP8 or VP9. This is possible. Of course, it increases latency. And we're kind of trying to do low latency stuff because we want to, from a remote control center, steer the ferry at some point. So we have abandoned this path for now. And we got back to what we know how to do. We wrote a new Android iOS app. It's called Ahoy on Board, which is basically just using the camera of the Android or iOS phone. And not just the camera, because those devices come with nice sensors. So we have a gyroscope in there, accelerometer, magnetometer, GPS, and especially gyroscope and accelerometer, you get the data with a very high frequency. You can do easily, I think 30, 50, 100 hertz of sensor data. GPS, unfortunately, only 1 hertz. But we use that data, and we are also encoding that data in the video stream because we want to collect training data for basically object detection, and for that we like to know where the camera is pointing. Also, you could measure where the sensor is mounted on the ship. That's possible, like you would do on a car for autonomous driving. But we have such the effects on the water, which are called waves. And then your camera is doing this all the time, and you would like to know what the orientation is. And we also use the WebRTC data channel to transmit it in a binary format. But for this collection of training data, we're encoding it in the video stream, and we are recording it on the device. But we're also transmitting that stream in real time. And that's what I would like to show you. Okay. Just reload this one. So I will start a stream from my Pixel 6, and then I will, let's see how this works. So what you're seeing, what I would call teletext at the bottom, is the black and white boxes where we encode 64-bit NTP timestamp derived from the GPS and all the gyroscope and accelerometer data. And what we can do is just in a web browser, we can make sure that the video seeing is kind of, how do we call it, upright. So if the waves are going, you kind of know where the horizon is. The horizon should always be horizontal. And that's we also have some information encoded with which zoom factor we are running this, and if there has been any modification to the data, because we're in Germany, and if we want to collect data, we have to make sure not to capture any personal data, not any faces recognizable. So what we will be doing on the phone is to do face detection, and then we will kind of pixel the faces, and in the frame we will set a bit that this frame has been modified and should not be used for machine learning later. Okay, and if you have any questions or
Very
ideas
nice.
on how I should do it better, please, now is the time.
Oh, well, if you give me that boat, I can think about some ideas to play, and then I'll give it to you. Okay. Questions here, Tim, of course, it's WebRTC.
So I'm wondering why you didn't use your own stack on the client side.
You mean for the camera? Because our stack doesn't do video, it just does the network layers and audio, and we can transparently transport video. But we didn't want to get into video encoding and decoding. I played around with GStreamer, which is an adventure in itself. But we have the Android and iOS cameras, and we had that for a while, so we know how it works. And it has a battery, it has a 5G modem, so kind of makes it a bit easier.
So answers were coming. So, okay. Giovanni with the last question, because you can approach, it's the coffee break after.
First one, and maybe a stupid curiosity, but how you implemented the deduplication with what kind of schema or libraries? Because
well, it's our custom software. So we have it's basically like RTP. You have a sequence number, and you see, have I received this sequence number already? Is it still in my window, or is it in the past? Then I just throw it away. So it's very simple.
So you make a hash and some repository with hashes.
I don't even use a hash. I just have some counters. So basically, like keeping track of RTP sequence numbers. We have our own sequence numbers, which don't easily roll around like RTP sequence numbers. So it's a bit easier to implement.
Okay.
But it's just counting.
Quick and dirty, but works. Okay, thank you so much for quite particular use case, and then
Yeah, hello, I'm Benjamin. We will talk about unit testing or whatever testing with Kamailio with Docker and SIPp. Let me start with the introduction. The main part came from Christian Berger, the famous guy over there. If you heard about teletext or fax, you maybe get in contact with his videos. Awesome stuff. Just check it out. And I'm Benjamin, and the whole team at Zipgate AWB, the famous octopus, just had his hands on that stuff. But let's start at the beginning. Let's make some gymnastics, all right? Who heard about Zipgate? Okay, who has an active Zipgate account? Okay, why does the others don't have one? Impossible. Okay, let's start at the beginning. I would like to introduce you to our internal unit testing solution to test different Kamailio roles in our setup. Let's start at the beginning. We had the task to upgrade the hardware and software of our customer-faced zip load balances. That are the first entry points to our VoIP network for all of our customers, like Snum phones or Grandstreams or whatever zip device. Scary stuff sometimes. Our tasks in detail were new hardware with vendor support. It's always nice. We needed a new Debian version, 11 in this case. We needed a new Kamailio version because we came from 5.1. It's still ancient, and we wanted as much valuable tests as necessary. Nobody needs to test useful and useless stuff, right? What we also wanted is that we wanted to test specific functionalities in our routing to reduce the amount of unwanted behavior during the rollout phase, right? So if we make changes to our code and we deploy it to our infrastructure, we wanted no interaction to ensure that the changes we made made some errors and customers are not able to make any phone calls. How hard can it be? Let's have a look at the setup. At first, we have some VoIP customers, which connect to our load balancer, which is just Kamailio. But one load balancer is really not enough, you know that. So we add a second one and have some reliability, and maybe we can reboot the one machine and things are still running. But more redundancy is good for sleeping, right? Everybody wants to sleep at night, so let's add 2 more load balancers. And in our case, we have an Anycast IP setup for all our load balancers. So in fact, every load balancer has one IP, the same one, where the customers can connect to. And they are all stateless. So it could happen that the VoIP customer sends us an invite to load balancer 1, and the load balancer is sending the invite to our proxy on the desktop. And the 100 Dragon, for example, comes back from load balancer 4. This is absolutely transparent for the customer, and that's our setup. So we don't care if one load balancer is crashing or rebooting or whatever it's doing. It's just not necessary to check it. But as I said, we have a proxy on the next side, so we have some more arrows between load balancers and customers. And once again, one proxy is not enough, so let's get crazy. So we have a nice bunch of arrows going to all directions, and yeah, how can we test that? The solution is simple: reduce that stuff. The fact that all load balancers and all proxy are doing more or less the same with the same code and the same IP, at least for the load balancer, we can just have one load balancer for testing, one for proxy, and one customer device. But to have that in kind of hardware or VM and things are just laying around, it's not very scriptable and useful in our CI/CD environment. We just decided to Dockerize that stuff. Right, reducing is not enough. So we implemented some Docker containers and set up Kamailio, the VoLTE phone, and the proxy on that side in own Docker containers, and try to implement some scripts. The fact, we changed the soft phone and the proxy to a simple SIPp in Docker, and the load balancers are just Kamailio in Docker with different versions. So we can enable our test setup to be scriptable. That's the next slide. Our first version of the test script we put on top of that was bash. In fact, it grew to 417 lines of bash with the finest bash loops, iteration, and functions you can imagine. This was just too much. We still use it because it works magically. And we have a second version for that script with Python. This is just a bit more programmatically useful, but it has also other reasons I will show you later. So what is the script doing? At first, it's building the containers in 3 different versions right now. In the future, there's a fourth, 5.7. And additionally, it's using Docker Compose and Docker to set up MySQL, the load balancers with configs, SIPp-proxy, and SIPp-customer. And then the last, what the script is doing is it's evaluating the SIPp return codes, checking the logs of SIPp, and gives back the okay or failing for the test cases we want. Yes. So in fact, we have a bunch of Docker images running. As you can see, some customer zip load balancer in different versions and roles like TLS and non-TLS and trunking, whatever the ZipPs, and some other containers that are necessary for our tests. And I will show you something from the Python script right now. In fact, it's just that. Okay, so we don't have main 417 lines. It's just defining the main functions, pathing the test cases, and starting them. Yeah. In detail, we pass the test cases from a specific folder inside our test setup, and all these test cases are just YAML-based files, which have some details I'll show you in the next slide. And it's just making some logging so that we can see some nice stuff, and then just run the test case. The test case function is using the Python Docker API to interact with the containers we created before. And yeah, the Kamailio container and some others are already up and waiting for things to happen. And as soon as the run test case function brings up the ZipP containers, things starting, and the magic happens. It's still awesome. Yeah, and as soon as the scenarios are finished, the ZipP return code is checked. And right now we have 420 lines of Python code. So it's not that smaller like the bash script, but it's Python, right? Next slide, please. Thank you. So this is an example YAML file for one simple invite test case. So as you can see, we have a middle container name, which is kind of, this is the Kamailio zip load balancer version we want to test. And then we have a nodes section where we specify the SIPp, proxy and customer scenario files and the key values that are necessary for the test. We can add something like expected return code 97,240, whatever SIPp is punching out if something is failing. But if we expect that, the test is okay, right? This could happen, and it's a nice thing to have that. Yes. Very fast today, but anyway. So let's use that thing. This is a snippet from the output of the test script. As you can see, it's just parsing the test cases from a specific folder and giving out some infos about that. And then it's starting the test. And as you can see, you can always see which test is running, how long does it take, and which scenario files are used. And if everything is fine, we have these nice green arrows at the end, and awesome. Finished. Yes. No, that was the wrong button. I don't want to make screenshots now. Here's a simple call flow from the simple call. As you can see on the left side is the customer SIPp, and it's just doing the invite trying, and that's what we want to see. Here's another example of a test case. You can see we wanted to test the message is too big feature of Kamailio. So if an invite comes to the zip load balancer and it's responding with message too big, in fact, we wait for this message and the test is okay, right? Yeah, what are we doing with this setup right now? We use that in our CI/CD pipeline. Whenever we want to deploy new features or changes in the Kamailio config of the load balancers, we push them to our repository or test that on our local machine. It's the same setup. And as soon as the commit is pushed to the repository, we create all the necessary packages that are needed to have a new setup for the Kamailio load balancer. And as soon as that happened, the tests that are on my local machine are also created, done on the CI/CD environment. So I don't have to do anything and can ensure that my changes are okay, that I test it locally on the machine and also on the CI/CD pipeline. So it's a double check if you want. If all tests are okay, the stuff is already automatically pushed to our dev environment, and if we think everything is cool, we can click go to live and have a nice weekend. What we want to implement next or achieve as next option is we want to generalize the test script that we can use it for every Kamailio instance we use or every role like load balancer or proxy or whatever Kamailio is doing, because in fact it's always SIPp left, SIPp right, and in the middle the Kamailio which is doing stuff, so we can just change the XML scenario files and check the return code. So it must be possible. What we checked in the past, we took a look at the CFGT modules, which is in fact doing more or less the same thing inside Kamailio. It's putting out some debug output for test stuff. It's written on the module side. Just take a look. I don't have it really in mind. And what we definitely want to do is using the statsd measurement module to get nice graphs, because it's always better to have some graphs, right? And let me go on the dangerous demo train, and let's have some fun. I have also SNgrep open, so let me show you at first the new Python script. It's just doing his job, right? And it's finished. As you can see, all the Docker containers are up and running. So I was able to start this stuff. And the other part that is very useful is that the fact that it's all Docker on my local machine, I can see all the traffic in SNgrep from every test case and can check every header or values or whatever on my local machine, and have a nice day. Yeah. The first thing was the Python script, which is doing not so much right now because of load balancer. We are just in the transitioning phase of using the Python script for the load balancers. We had the shell script, as I mentioned before, version 1, which is doing all the tests. And let me start that. And this thing takes 15 minutes or so. So you can see some tests take a bit longer because we have some tests which are going to Kamailio and he's just doing nothing because sometimes we have a bad user agent which is just dropped. So we don't get any answer from Kamailio and just wait for nothing. But okay. Yeah, that is more or less everything from my talk. Thanks for the fish. That are all the Unicode things we use in the script.
Thank you. Thank you. Questions, Ihor?
Yeah, thanks. I have two actually questions. First one, have you considered somehow to extend it to end-to-end testing and not the unit?
We have already end-to-end tests.
Then how you do, for example, a quite simple scenario with a SIPp register and wait for the call? Have you considered to do it? For example,
we do that already.
on SIPp?
Yeah.
Okay, would be
So
interesting to look at.
Okay, this is a very old thing. I think the red guy did that in the past. I'm not quite sure. So in fact, we have a shell script which is starting the ZIP, which is doing the register part to a real account of zipgate. And then the second ZIP instance, which is doing the call all through our environment, and it's doing a real user call. So this is our end-to-end test we have already, but the little unit tests we needed right now because we had many changes to do and wanted to sleep.
Yeah, and the second one, have you tried to make it in a parallel testing way? Not one by one test, but all of them run in parallel.
Yeah, but no. Yeah, the fact we could set up for every test a single Docker setup, but this just, my laptop would just blow. So we have the focus on, we want to make local changes and test it on local machine, and maybe a CI/CD pipeline environment is able to sum up 10, 20 tests at once, but not my poor laptop. Okay. Any other question? Yeah, Sebastian.
How does the configuration get into your Docker containers? I mean, you're testing configuration changes, but
Yeah.
how does the configuration get in there?
It's just in the repository of the load balancer. So we separated the customer mod param part, so the Kamailio header stuff, if you want, and the root part is just code, and we separated that part into a single file, and this file is in the repository of load balancer with all the tests, and if we make the changes in this root file, it's pushed to our CI/CD pipeline, and then this thing is creating a Debian package as usual and installing this root file as routing config for Kamailio. And when the packaging is done, the tests are starting right after the building of the package, because then we can install it in the Docker environment, like get update or get install Kamailio routing version right now. And then we have this change in the Docker container as soon as it's pushed. Yes.
How are you dealing with external dependency for the Kamailio? Let's say if you use a database or MQTT, something like that, do you have another Docker container for that per particular
I
dependency?
don't get your question, sorry. Just speak louder.
How you are dealing with the Kamailio dependency? Let's say if you use a database.
Yes.
Do you have a Docker container for database?
Yes. We just bring up a MySQL container, and we have this fancy Docker feature that we wait if it's ready to serve some data, and then we bring up the other containers, and then everything is just working. So we just put some demo data in the database and use that what we need for the test setup. So
Do you generate those fuzzy data from some scripts or getting from the production database?
No, we just used our fingers and put in the numbers. Okay. But there was no fancy script at that time because we just had a little. It's just a focus to the load balancer stuff, and there we don't need that much data in the database.
Okay, no problem. Thank you.
Yeah. Yeah, I think.
How many configurations or test scenarios do you have, and is it ever enough?
Yeah. Second questions first. Yes. We have a commitment to not test the Kamailio functions, but the routing we does. So whenever we, more or less, we have some tests where we test the Kamailio functions, but we don't test something like, did Kamailio choose a right dispatching stuff with DS select whatever, because we trust Daniel that everything is okay. But you can say as soon as we have an if in the routing config, this is a good candidate for the unit test, right? So we can say if blah, we expect this one, then we have a test for that, and else we have another test for that. And this is what we are testing. And the amount of tests, I think it's not that much. I don't want to stop that. It's sure. As you can see, we have a lot of SNgrep stuff going on, right? Some rejecting and so. No, I can't say that. I have to, but not now. It's too much stuff, right? It's taking 15 minutes. I think it's around 40, 30 tests, which make many calls sometimes. The most interesting ones are the Pike tests we do. We have to ensure that Pike is working. So for example, if we send 600 calls in 5 seconds, we want to ensure that Pike is working, and then we expect one message with, oh, this call was it's blocked by Pike, so that's it. And then no other message because we just drop. And this is just SIPp magic and return code guessing and just dropping the tests after a while because there's no response from Kamailio. So this is kind of tricky, but yes, that worked.
Nice. Thank you. Thank you.
Yes.
Benjamin, the entire SIPgate team.
Going to go down. Oh, I've broken it already. So we have a batting order. Each presenter 3 minutes, ruthlessly enforced, with a minute to change over. At the end of the competitions, we're going to start off with the audience vote. The way that we're doing the audience vote this year is that you will be given a telephone number, a mobile phone number, a UK number, and you then send a vote with a number in to that number. If your vote is a valid one, and there are a number of artificial intelligence-based things going on in the background, you will receive back an acknowledgement from a completely different place. The purpose of that is to make sure that you're voting from a real phone and not a virtual one that we've had many times before. And you are only allowed to vote once from each phone. So if you change your vote or try and vote again, then you'll get a message back saying your vote has been changed. So there we are. We try to make it a little bit more difficult to cheat this time. So the judges we have TJ. TJ, have you got the spreadsheet? Eyes. Oh, God. Well, you will have the spreadsheet shortly. And Mierla, you can use my MacBook. First up is going to be Sandro, who is going to demonstrate his new little attack tool, I think. Is that right? And he is going to be ably assisted by Fred, who is being a willing victim for this. So good luck, Fred. I'm not totally sure how you're going to administer this. So would you like to come up? Because you're attempting something very difficult, Sandro, we'll give you a couple of minutes just to explain how you're going to do this. So would you like to come up now? All right. And just to remind you, the prizes are here. They're laser engraved lead crystal trophies at produced at huge expense, paid for by me personally this year for lots of complicated reasons. And they will be awarded at the end. Right, Sandro, are you ready? I think the desk microphone is live. You want to use that?
Yep. All right, so what do we have? We have broken screen. Let's try Zen again. No. So Zen is not Zen. All right. So yeah, we have our new attack platform, and we thought we would do a dangerous demo with that. So there's two components here. There's the attack platform, of course, which is kind of controlled through CI/CD pipelines, and we use the CI/CD pipelines to start and stop attacks. But the truth is, the attack platform is independent of the pipelines. Anyway, we have prepared a couple of tests thanks to Alfred, who's been, he's a bit more stressed than I am, I think. So we have 5 different tests just in case one doesn't work. And these tests will be run from 5 different small attack nodes. Each have a couple of IP addresses. And we usually distribute these attacks across all nodes, so we usually have a bigger IP address space, but to send the attack from. But this time we did 1 node per test, so there's just these 15 or 16 IP addresses per node per test, just in case Fred's machine blocks us on one test. We want to be able to continue. And then there's the target, and that's set up by Fred and his colleague. Thanks very much, Fred, for being a potential victim and volunteering. And also there's the specs, which are quite low, actually. I'm not very happy with that, but we'll see. And it's set up to block us upon potential attack. I don't know if Fred wants to add anything. Where is Fred? Yeah.
You have to be quick, Fred.
Yeah.
Okay, well, that's enough of a preamble.
Yeah.
I think this is where we start the clock. And Sandro, you have exactly 3 minutes to completely vaporize Fred's machine. Go.
All right, we're gonna start with the first one then. I don't have time for other things. So this is just an invite DDoS flood. I'll just go in there so that we get some feedback. Oh my God, the screen. So yeah, of course, it's using Docker and all the cool stuff, which takes a while. And what happened? Network error, timeout detected. Well, do you have any feedback, Fred?
I'm gonna start my blocking now.
Yeah, there's blocking, yeah.
Yeah.
But the blocking doesn't.
So I started it out without doing IP tables block. I just started that. I reduced. Oh my God! All right, one second. All right, I reduced CPU, but the system's still not happy at all.
I don't know. The attack has stopped already. Okay, so it should
I'm
be.
still getting within
Oh
dialogue.
no! Sorry. I can stop it. Let me stop that.
It's nice.
It's 1 minute 4 seconds of attack. Okay, a bit less. All right. Can you manage?
Yeah, no, I can manage it. Yeah, because I've blocked some of the other ones. Clearly, you've got things that have evaded blocks, which is awesome on you and not me.
With this test, we did not plan to evade any blocks. Okay, so something to be seen later. The next test is the in dialogue invite DDoS, and this will evade blocks. This usually does. Do we do that, Fred, or is it too much?
Oh, go for it. I mean,
All right. So yeah. What we do here is instead of sending, an invite that is initiating, a dialogue, we send an invite that appears to be in dialogue. And that usually bypasses a lot of restrictions that are a lot of checks.
yeah, I mean, you got the Pike saved me on a couple of them.
Is it?
Yeah, Pike, you hit Pike, and then I blocked it because it hit Piked, so I blocked some of the IP, but damn. That came in.
So are you able to run calls through or not?
Yeah, I can. I still have connectivity right now.
Okay. Do you have a soft phone to run?
Oh wait, no, I just lost connection to the box. All right, no wait. All right, here it is again. You still have some notifies that are evading. I mean, my bandwidth is gone. I'm clearly impacted. No, I wouldn't feel comfortable doing a. Can't even run top yet.
And that's your time up. But I think the moral of the story is don't upset Sandro because you might.
I'm working on my anger management. Thank you.
Okay, thank you. Next up, Carsten. So Carsten is a veteran of dangerous demos. He has done so many dangerous demos. I think we've lost count. I think on balance, more have failed than have actually worked. So I suspect, well, I don't know. We'll have to find out. But Carsten could be going for the crash and burn prize.
Not this time.
Okay, and this one is all about going back to the future, isn't it? Back to Astricon 2017.
Exactly. And I'm really happy that you didn't find what I presented back then, because otherwise I might have won a prize for bringing up old ideas.
Okay. Are you ready to go?
I'm ready to go.
Okay. Would you like to start the clock now?
Okay. So I'm doing a very dangerous demo today, and I think it's dangerous because of multiple reasons. One reason is because I'm involving a colleague of mine, which didn't really, who doesn't know what he's up to. And the key point why I implemented this dangerous demo is because I really like real life examples. And my wife is very much helping refugees at the moment from Ukraine. And the biggest challenge that they have is language. They don't speak German, they don't speak anything. So I thought, let's do a real-time live translation. I used research for this, and now I'm gonna make a call. Just a moment, using my regular phone. Let's see if it works.
400 HTTP 1400 bad request.
Okay, that's not the way it was supposed to be. Apparently it's, yeah.
Hello?
You should hear something?
No, it dropped.
It dropped, yeah, exactly, because I hang up. Trash and burn. Wait. Let me quickly see why. Okay. A little bit embarrassing, to be honest, but can you?
Silence the car?
The
call is ongoing.
The call is ongoing. Okay. So maybe you can say something in Ukraine, please.
When the piercing heals, congratulations.
Okay, so this is my dangerous demo. Thank you for your participation, Andrew. This should be a real live translation of my call. Yeah. Let me quickly explain why this is better than the last demo I did, because apparently my programming skills got better. Open source got so much better over the years, and today we speak way more languages. And it's becoming a real use case, which is really exciting. To be honest, I've used a lot of Google on this demo, and this is definitely not GDPR compliant. That's why I think Banafo and his voice translation, ASR, speech synthesis, is such a great idea. Thank you.
Okay, thank you. Okay, next up, we got Alexander. We've got a slight rescheduling. you want to come up now, Alexander, to give Andre a little bit more time to get his demo working? I love this. Looking out in the audience and seeing people working very hard on getting their demo working. So Alexander is going to do a practical demonstration of his new thing with lots of letters in, which is very exciting. But I arrived about 2 minutes too late to watch it in action. So Alexander, are you ready to rock and roll?
Yep.
In which case, would you like to start the clock? You've got 3 minutes.
So it's Monday. I present eBPF. So it was some about how we can capture everything without even knowing certificate TOS version 3. Thanks. I would like to say thanks, Mira, because I use your ZOIPer to make TOS connection to Kamailio because in Linphone did not work. So thank you so much for the license. It's helped a lot. So just show. Here we start. Sorry? Okay. ngrep, we start our ZOIPer. It's make this TOS connection. We start our RTCP agent, which will make a hooks and see all the decrypted messages from kernel side without no certificate. We make connection, so make a call. We see it's decrypted. We will check if it was decrypted. And we go to Homer. We make a search for this call. We click. And what we see? It's TOS. And this was decrypted. Without... So, just, I'm not lying. Let's go to and check if Kamailio doesn't have any zip capture module installed. As you see, it doesn't. And it's, anyway, it works well. Thank you.
Okay, thank you for that. That's a good one. Exactly what we'd expect from you, Alexander. So another reschedule. Andre is still working. Oh no, well we've got Zoa on next. So you will be on next, Andre. So again, Zoa, yet another a veteran of dangerous demos, and for the record, I am this morning wearing my Banafo socks. Just for Mira and for Zoa. So, are you're not quite ready yet? We've got to find some video from somewhere. It's hiding in there somewhere.
Well, that's a good start.
Not a good start, no. Most people get... Do we need a little bit of assistance with the video?
Maybe here.
Dangerous demos are like this. You never know what's going to happen. Just to let you know, we've had one withdrawal, and that's Giovanni. Have you got it working now? No, it's not working, exactly. So Giovanni has crashed and burned on the launch pad and is withdrawing, but we've kept his name on the sheet just to shame him. Yeah, we noticed the lack of practical demonstration first thing this morning, and the very hastily prepared slide pack. But a good recovery. Okay.
So I'm actually going to try to do two demos. So maybe you'll be a little bit easy on me on the timing for this.
Yeah.
I was hoping for Mira to do this.
We got a Belgian on the timer, so.
Exactly. So.
Okay, you have 3 minutes. I have to talk quickly, starting from now.
Okay, so but I need a native speaker, so I will actually need you, James.
You want me?
Yes, yes.
Oh, gosh.
So I'm going to try to do two things very quickly. The first part is I would like to try in English real-time transcriptions. Here, you can use real-time transcriptions with non-existent words. I asked ChatGPT to make up some words, so can you read the things on the bottom?
Did you hear about James
Oh,
Bodie?
wait. Go ahead.
Did you hear about James Bodie amidst his 5G Schnitzel flits in Italy? It's rumoured he clandestinely trained with a legendary Italian sniper. Now he's using the skilly wiggles for pinpoint blibbery accuracy in his work and has earned the nickname the Telecom Sniper. Can you believe our very own James has become a legendario in the Italian countryside?
Okay, so far for the first part. We have a German one too, but probably don't have time for it. So, oops. No, that didn't go well.
That didn't go well. I like the way it called me Jane Spoody. Nice.
So for the offline models, probably are better with the non-existent words. We do train on some made-up stuff just to make this possible. Let's see for this one though. So this one is a bit faked. I will try to give a file for it. It's pre-recorded because I need to have the proper format. So this second demo is using WebAssembly to do real-time transcripts in the browser. So there's no server component to it at all. And I'll already start it. Well, it's going to take a while. It's running locally, completely, and it's actually streaming audio. But it's in this case, it's a file which is being read as if it is streaming because we didn't have any time to implement anything microphone related. And this is the result. And I actually use some online text-to-speech to generate the WAV file because I did it this morning while, oops. This is not looking good on my screen, so I'll disconnect it. So yeah, this is just using some random TTS thing that I found online because I couldn't really record my voice while I was sitting here, so that's why probably Joachim is not very good. That's it.
Whoa. Okay, Andre, would you like to come up now? So I'm still trying to work out who Jane Snooty is, or Snoopy or something, and trying to work out what actually went on in that demo. That was interesting. Thank you for that, Joachim. Right, Andre, who is a first-time dangerous demoer, which is good to see, and he is going to connect something to SIPgate. I hope SIPgate you're aware of this. Whether it actually ends up taking SIPgate down or not remains to be seen.
Okay.
Whether it works. Are you ready, Andre?
Yes.
You are. In which case, shall we start the timer now, please?
Okay, so the idea is to demonstrate how easy it is to connect a WebTreat to any VoIP system. In this case, Marcus from SIPgate was kind enough to provide some SIP credentials for me. I was trying to demonstrate the full cycle of retrieving information from DynamoDB. That is not working yet. I'll follow up, but so far we'll be just emulating with Firestore, which is, I'm more familiar with Google Cloud. So the idea is we just need some type of user record. And in this case, these are the SIP credentials which were provided by Marcus. I have them in Firestore and the adapter which does the connection. It is a Python fast API application running, in my case, it is in Google Cloud, can be deployed in any platform of your choice. And the only thing which you need to do in that adapter is to implement a few simple methods, like how do you authenticate the customer? If you need to do OTPs, you implement them. If not, you just skip them. How to retrieve information about specific user or SIP endpoint, how to retrieve contacts, and the rest is optional if you want to have history of CDRs, if you want to have call recordings, and so on. So right now, the user data are in the demo system, and we have them. So we have extension X62, and then we have X63.
this one. That's done. 63. So my goal is to have a web client running on my PC, connecting to web client running on my phone, and the call will go through WebTree and then through SIPgate. Okay. So we have our 2 users, and now I have to log in my phone.
Oh!
Oh, yeah.
So close. But I think we can see where that one was going, Andre.
Okay.
Which is good. And by the way, you might want to consider changing the password on your SIPgate account. That broadcast globally.
Yeah. That's it.
That's what dangerous demos are all about. So, Lorenzo.
HDMI or HDMI?
So, my good friend Lorenzo, again another seasoned veteran of dangerous demos, this time without his guitar, I'm pleased to say. And I think that this demo has got something to do with emergencies. So I'll wait for Lorenzo to look up with an excited expression saying, I'm ready to go.
Yeah, just a second.
Which I don't have at the moment.
Yeah.
Okay, we're ready to go. Are we ready with the timer? Lorenzo, your time starts now.
Okay, so later after lunch, I'll be talking about real-time text in SIPp and WebRTC. So I just wanted to make a demo out of it. So in this case, for instance, you see a web page that will use Janus, that I use Janus to register at the Kamailio instance that I have here. And then I'll wait for a SIPp endpoint with real-time text support to call me. But using real-time text endpoints is boring, so I'll just use a video game instead. So basically, in my spare time, I've been working on creating my own point-and-click adventure game engine. So any Monkey Island fans in the house? That's the kind of vibe that I was going for. So, and basically, since I control the code, I created a plugin that allows me to send, to do SIPp calls and real-time text as part of that. And I hooked all of that to this nice old-style payphone over here that we can have a look. We can examine just to have a look. Yeah, some snarky remarks over here. So, I mean, payphones are really something that you don't really expect to see anymore, you know, so that kind of thing. So, but of course, the examining things is not really that funny. So let's see if it actually works when I want to actually use this payphone to do something. So I'll click on the payphone and hopefully I'll see a call happening over there. Ah, yeah, you see the character said it's ringing. So let's accept the call. Okay, now we have a session setting up, so the character is just saying a few things. So yeah, you notice that it's just text only, so he now simulates the fact that he's actually, you see he's writing some text over there, it's really nice. And of course, receiving text is nice, but we also want to send text. And so I hooked it up so that everything that I send is used in real time as fake keyboard input to the video game. So if I press 1 over here, the screen becomes smaller, or 2 or 3. And I can also use it, if I enable the debug console that shows over there, I can use it to send commands, like, for instance, active actor. I can also go back, as you see, actor, look down. And you see it's changed direction, or maybe something like active actor, say, then I left to, okay. Actor, say, and that's basically all. Well, last thing that we can do is commit suicide by just, I mean, this is all Lua based, so I can just send the hang up call method, which will go to the game will invoke the plugin and will send the SIPp by, which means that I should see the call hanging up here as well, and I'm done. Thank you very much.
Thank you, Lorenzo. Absolutely nothing to do with emergency calling at all, really.
I mean, there was real-time text in there.
Yeah,
so
real-time text. Okay, next up is Wolfgang, without stickers this year, I hope, which probably will have emergency calls on. And then after Wolfgang is Frank. So you ready, Frank? Give me a wave. Yes, there's a nod from Frank. So I will continue to burble on a little bit whilst Wolfgang gets connected. So a little bit of explanation about the sticker thing. Wolfgang, a couple of years ago, 4 years ago, 5 years ago, demonstrated emergency calling for people who can't speak. And to illustrate that, he had a Kamailio sticker stuck on his mouth to prove that he can't speak. That's right, isn't it? Yeah.
Yeah, it's totally right. Yeah, thanks.
Yeah.
Thanks for that nice intro.
Are you ready to go now?
I should be ready. Yeah. So
almost.
Actually,
stuff.
Yeah. Just following the patterns of the previous demonstration. So it's very important for you to dress up smart if you want to succeed in a demonstration. At least as smart as James. Yeah.
I have my orange
James, you don't want to see this, but I do.
Oh, we have stickers.
So, but I don't need them. And what I've also seen is just open up a terminal window and show something. It's not important what you're showing in the terminal. So
are you ready to start, Wolfgang?
I'm already in the demonstration.
Oh, well,
yeah.
Let's start the clock then.
Okay. Yeah, so some success factors. So have a terminal open, show something in the terminal, then perhaps log on to something that runs in the cloud. So that's Frequentis dispatch position. So we do call handling equipment for emergency communication centers. And let me log on there. So it'll be 112 call data then. And I do have some very specific actions here. It's about data. And this is a viewer for text chats. And actually, what you should not forget is what you actually want to demonstrate. So I have another slide somewhere showing some information for you. So the idea here in the demonstration is to get a signal chat into an emergency services IP network, use the location that you provide with signal, and then have some real-time chat. So if you do have a signal application, just use the QR code or open it. There's a number you can use. And if it's, I think if it's iOS, then the plus button is on the left side. I do have one application, so if you don't have one, just to show how this works, let me get back. Wow, there are already some calls coming in or some chats. So perhaps you did not provide the location because we are somewhere, yeah. So let me try. Did someone provide a location? No? Okay, then let me do this with the location just to show how it works. You have to press the plus, then the location and forward location. Which one is the last one? Perhaps the topmost. Oh, yes, you see here, that's the location, and just want to say hello.
You probably want to say help, actually.
Oh, that was last time with the ticket. Okay, yeah, that's actually it.
Thank you, Wolfgang. And not... That's actually quite a cool demo, but it's worth pointing out that not a single sticker was harmed in that demonstration. So thank you for that. And there's some really good real-world use cases for that. Yeah. Great. Okay, next up is Frank. And Frank, I don't think we've had the pleasure of having you do a dangerous demo before, have we?
No.
So another first time.
And it's my first time here, so.
Yeah. Just to prove that we are very keen to get people who haven't done dangerous demos before. So this one is all about, and I've lost me sheet.
Great.
Oh yeah, offering a little
Wow,
finger.
This is my
isn't it?
second screen. This is going to be interesting.
Well, we'll give you another couple of seconds to sort that out. Oh, that's looking good. Is that what you want to see?
This is what I want to see.
Okay, are you ready, Frank?
I hope.
You hope. This is Dangerous Demos. You have 3 minutes starting from now.
Okay, in my last lecture, I said that we provided that protocol and that we were asked if we could tunnel REST APIs through there. And this is what we expected. There's the REST API there, and this is a nice response. And then we looked into our logs, and suddenly we had like these things here. That was not what we expected. So yes, this was definitely not what we expected. And if you want to see what that can do to a system, there is this is very awkward with the delay, not seeing it here. This is a little script that I can use to actually generate some load, shooting some REST API at a server right away. But I maybe should execute it instead of showing it. That would look better. Okay, now we don't see anything here, but when we look into this thing here, we can actually see what Kamailio does right now. It seems to be a little bit busy. Let's see what the server does. Yeah, maybe that was not such a good idea. We solved it by now, but this is what happened. I'm done.
That was interesting, Frank. I was just still trying to work out what was going on there.
Oh, I maybe should stop that thing before.
Yeah, that's good stuff. But anyway, thank you for that. I hope you got that, Mierla. She nods wisely. Okay, next up is Davy Vandermoor, all the way from the land of Tintin. Another Belgian, aka Dangerous Davy, who has a reputation for doing all kinds of dangerous things.
Sometimes it's success.
Yeah, sometimes success, sometimes not quite so successful. But there we are. So the Davy's demo today is going to involve the audience, I think.
Absolutely.
Okay, we always like a bit of audience participation. I'll give you a few more seconds whilst you get yourself ready. That looks complicated.
Well, no, just some logs.
Particularly with the Joachim thing.
Yeah, I just found out that Joachim and me, we gave a presentation on Astricon on the performance of Asterisk like 15 years ago. It's great to Google it. There's some fun slides in it, and it's great to see where we were then. Like then we were excited when we had like 400 calls on one machine. Today we just laugh our asses off it with 4,000.
400 calls on an Asterisk instance.
Yeah,
I mean,
absolutely.
that's going for it.
And at that time, we considered Asterisk being the best thing in the planet.
Yeah.
At that time, of course.
Yeah, those were the happy, heady days, weren't they?
Yeah, that was cool.
Before 5G.
So talking about technology and evolution.
Are you ready to go?
Yes, good
Okay,
to go.
in which case, let's start the clock.
Voila, it starts with, I need a question from the audience to show you that I'm not cheating. So something you could ask ChatGPT. Mira, something philosophical or physical. Anyone? Okay, then I'll pick one. Can you hear that?
Oh, please ask your question.
Why is the sky blue?
We are analyzing your request.
You can follow it. You can follow it on the screen. Eh? So it's now uploading, doing all sort of stuff to it.
I'm sorry, Dave. I'm afraid I can't do that. Why is the sky blue? The sky appears blue to the human eye because of a phenomenon called Rayleigh scattering. Essentially, when sunlight enters the Earth's atmosphere, molecules like nitrogen and oxygen scatter the sunlight in all different directions. Blue light has a shorter wavelength that is scattered more.
Yada, yada, yada. So that worked.
Right, how many seconds we got? Can we do another question?
Oh.
Okay, come on, another question. Put your hand up if you've got a question to ask.
Ah. Don't make it too long and then it crashes.
Who is the author of Kamailio?
All right. Ooh, that would be fun.
That could be a tricky question because of the pausing.
Yeah, it's...
Oh. Didn't like that, did it?
It's telecom, man. PSTN. Does Dirk have
I think you said
Please ask your question.
Who is the author of Kamailio?
We are analyzing your request.
It will do the same joke, eh?
I'm sorry, Dave. I'm afraid I can't do that.
And then
Who is the author of Chameleon?
Chameleon. Yeah, close. I should have said
As an
Kamailio.
AI language model, I am not sure which book named Chameleon you are referring to. There are several books with the same title by different authors. Can you please provide me with the full name of the author or more context so that I can assist you better?
Well done, David. So that one kind of worked. So that was good. Now saving the best of the best to last. The master of dangerous demos himself. Yeah, little known fact. I think it was at a TAD hack. No, not a TAD something. Summit.
TAD Summit.
TAD Summit. Daniel accepted a challenge to put an entire mobile core on an Ubuntu handset, and then proceeded to connect that to a cell and give service in the room. And if that wasn't enough, he then loaded it up with traffic to see how many concurrent calls he could get through the thing before it melted. So that was an awesome demo, and all written from a standing start. Daniel even had his coding hat on for that one, so that it gives you some idea of how intense that one was. But anyway, Daniel, looks like you're ready. You have 3 minutes starting from now.
Yep. So actually, this is trying to show that during the workshop on Monday, when I tried to connect to the database with KEMI-CLI, it failed quite badly. But yeah, the reason was some incompatibility on the library that was used by the tool. It was an exception, but for me, reading Python exception, it's worse than my German. So I'm not a Python developer, but in the evening I checked, and actually the SQL Alchemy version was no longer compatible. That happens when you use for production all stable and for demos new version of the operating system. So it's like a simple commit. So now I'm trying to show that in whatever time I have left, I can deploy KEMI-CLI and then connect to the database. So database is already running. So I'm trying to follow the commands here with the virtual environment. Let me find. I know them by heart, but I'm trying to show that you can copy and paste. Hopefully, good enough. So let's paste it here as I usually do it. So now let's activate the environment, then activate. Let's clone KEMI-CLI. Okay. Then I have to install the requirements, like here. let's be sure that SQL Alchemy is less than the new version. That looks good. We need to connect to MySQL database. Let's deploy KEMI. So yeah, this will make it available, but KEMI. Oops, sorry, what I copied. And now let's see, KEMI db show subscriber. I can connect. I can connect to the shell and also here use db show subscriber. I can add subscribers here in the shell. Subscriber. Let's use add Carol, a strong password for Sandro here. And now let's see what's in the web Carol. In time. Thank you. So yeah, it's easy to install, but it was just.
Yeah, thank you, Daniel. So it's always reassuring to know that the command line interface does live in the 21st century. So CAM-CLI is alive and well. Right, that was the last of the demos. Yeah, we're going to swap over and we're going to go into the audience vote component now. As we're getting set up, it's worth pointing out that we have a member of the Dangerous Demo team who can't be here with us today. He's still back in UK. So in a second, if we're very lucky, we will bring him up so that you'll be able to talk to him very briefly and he can explain how we're going to do. Yeah, lost him now. Where is he? There he is, Andy. And this is not working. Why is this not working? Because a dangerous demo. Here we go. And I do apologize. This is Google Meet, but that's only because we want it to work. It's not open source. Joining Andy. Hopefully, we'll have an Andy. There he is. Oh, let me turn him up. Okay, tell us what's going to happen next, Andy.
Okay, well, I'm hoping you can hear me okay. Can you hear me?
Yes.
Good, excellent. Hello, everybody there in Berlin, in Fraunhofer Institute. It's nice not to be there, but it's not nice not to be there. Right, so the Dangerous Demo voting system will be exactly the same, really, in terms of interface as it has been for years, which is basically you choose which of those contestants you wish to vote for, you note their number, and you send a text message to the number that is on the screen there in front of you with nothing more than that number in it. And it will then record your vote. Now, as James said at the beginning of this, if you vote more than once, if you vote for the same person more than once, the second vote will be ignored. If you vote for a different person, it will change your vote. So you can do tactical voting here as well.
Okay.
Look and see where we've got to.
Are you going to... Are you going to switch the screen or shall I? I can do it if you don't want to.
No, I'll do it. There you go.
Yeah, we haven't... yeah, you'll get it in a second, don't worry. Oh, Andy, come on. You're not sharing. We don't want to look at that one. It's this one. Is that right?
It would appear to be right. I think Lorenzo might be winning this a little.
Yeah, I'm amazed. Well, I'm relieved to see that Giovanni hasn't got any votes.
Oh, he has.
Oh, Giovanni has got a vote. He says, you've changed your vote. The number is at the top of the screen. The list of participants.
I can't show you them both at the same time. So. It's contestant.
There we
not
go.
PHP.
There we go.
Okay.
That's what you want, isn't it? Yeah, I'm showing that now. So Sandro is 1, Carsten is 2, Daniel, for some reason, is now number 3.
No, it's not.
Well, it says number 3 on here. Why is that?
I would refresh your screen.
Refreshing now. Oh, there we go. Well, that's just to confuse people, isn't it? So Andre is 3, Alexander 4, Lorenzo 5, Joachim is 6, Wolfgang is 7, Frank 8, Giovanni, do not vote for Giovanni, he doesn't deserve it. Dangerous Davey is 10, and good old Daniel is 11. So let's quickly go back to the live results. That's interesting. So it's looking like we have a clear winner. Should we run it a little bit longer? Oh, what's this? Davies got a few fans all of a sudden. But Lorenzo is still way out in front. So I think we have a winner of the audience participation prize. And it's Lorenzo. So have we got a prize? Or are you going to do those at the end? We'll do them at the end. Okay. All right. So, Andy, let me just flick back to you. Any final words you want to give to the audience?
Drink lots of beer.
Thank you for that. Thank you, Andy.
Thank you, Andy. Good.
Hey. Okay, so that's the first one done. So can I go back to the running order? That one. So the next prize goes to the Swan Prize. So the Swan Prize goes to the most beautiful demo that it was not really dangerous at all. And if you can imagine a swan gliding across a lake with leaving virtually no ripples, but underneath the water, the legs are working very hard at that. Ooh, that's what the Swan Prize is all about. So I don't know what that was. I'm looking at Mierla because Mierla and TJ have to give us a name in about 10 seconds. So the Swan Prize, would you like to start off by saying why you're awarding the Swan Prize to this person and then give us the name? Mierla, don't worry me. You've done this so many times before.
Yes, absolutely. We are debating between two persons at the moment. It's extremely close. So 1 second to debate. Okay. As the debate goes on. Neck and neck. Who will take the coveted Swan Prize? Incidentally, we designed the Swan Prize actually for ClueCon, because Alexander Minisala, the author of Free Switch, always used to do these absolutely brilliant demos, and they looked totally effortless. But he never got a prize because it wasn't dangerous. So we thought we better invent a prize that Anthony could win. And since then, he seems to get it every time at ClueCon. But anyway, do we have a name, Mira? We have a name, and the Swan Prize goes to Alexander.
Alexander! Okay. Yeah, we'll do the prizes at the end.
At the end prize.
Okay. Next one, the coveted Crash and Burn prize. And no, you can't have it, Giovanni, because you've got to compete to get a Crash and Burn prize. So again, it looks like we've got a tie on the Crash and Burn. Ooh. So when you're ready, Mira. Oh, look, it's difficult. They're looking at each other.
We are debating. It's such a
Whose
intense process. We're looking at it.
Yeah, just to remind you that the Crash and Burn goes to somebody who not only crashes and burns, but does it with great style and panache.
So it's the manner of your failure that really matters here. So who failed the best, in the best way?
We actually didn't see any failure. We only saw one person not being able to finish on time. So,
so what do you reckon? God,
Yeah.
TJ, what do you think?
Complicated.
Just give us a name.
we're going to give it to Carsten, although it
Carsten!
didn't crash and burn.
Okay.
It actually worked.
Okay. And strangely enough, Carsten, I don't think it's the first crash and burn you've actually won, is it? No, he's so modest. Okay, and now the star prize, the one for the most entertaining dangerous demo that actually worked. Have you got a name?
Yeah, that one is very easy for me.
Okay.
Yeah, is it easy for you?
Go ahead.
Oh, so I was bribed in advance, so that one goes to Zoa.
Okay. Joachim, where you are here?
All right. Can we have all of the prize winners? So that's Lorenzo and Alexander, Carsten and Joachim. Would you like to come down and receive your prizes, please?
James, I see another prize here. It is Kia's demo.
One prize.
One. We'll face the camera. There we go. There we go. Take this back to Hamburg. Pride. Absolutely no pictures of library.
Okay, don't leave because we also give. Okay, those are really nice. We had someone
More
that
prizes.
worked, so we'll give the prize for audience to. It's a snow all three. It's the biggest snow because it's the base station and no desk phone, handset, and base station. With SIPp support, you have to add the WebRTC support to it. That was the requirement from them. Thank you, Lorenzo. And another one that we want to give to the other participants that were brave to show us. And of course, we have to give it to someone that works with Kamailio. And Frank, you got a book.
Well done, Frank.
As you work with Kamailio. Yeah. Lorenzo you can stay here, yeah, for the final photo. Thank you, everyone. Lorenzo plugging in the Kamailio in the demo was the extra point that we gave it. Thank you.
Okay, thank you. It's just worth saying that we will be doing dangerous demos, but not as a competition at ComCon end of this month. If you want to go, there are still tickets. comcom.xyz if you're American, XYZ if you're not. And the next competition for dangerous demos will be held at ClueCon in Chicago. So Americans, you get your chance too in August of this year. So thank you all.
Thank you all, and food is waiting for you for lunch. Thank you. Break for lunch now. Thanks, Maksym, for coming here and looking forward to the next version of the RTPProxy to see what's going to be in. Thank you.
Thank you, Daniel. Thanks, everyone. It's our pleasure to be here. It's second time at Kamailio World. Last time I did not present. This time, hopefully, not the last time. Anyway, so a little bit of introduction. Well, let's start with the agenda. So we'll go with introduction. I'll give you a little bit of history of RTPProxy. Then I'll go over to our evolution of the RTPProxy architecture since 1.0. And the last I will talk a little bit about what's new in RTPProxy 3.0, which we just released last month, and talk a little bit about what's next. So a little bit about myself. Born and raised in Ukraine. I have a master's in physics and radio physics from Kyiv State University. About 17 years ago, I moved to Vancouver, Canada, and I have been living there since father of 3 as well. So about 15 years ago, I started my own business called SIPp Software, and we provide small and medium companies with affordable and reliable solutions for switching SIP calls. Our focus has always been on the cost of ownership and the reliability of the system. Most of our customers are not too technical, so we're basically catering to people who don't have like huge R&D teams and but still need to process quite a lot of calls. Doing pretty okay. Team has been growing over the years, and we're powering quite a lot of small carriers and call centers and whatnot all over the globe. So how it all began? Like as Daniel said, it's it's me. Like 20 years ago, as you can see, there is and that's pretty much how RTPProxy started. So we basically, I joined the SIP industry in 2003, and we started looking at implementing pretty much soft switch using open source tools. I've been before joining like commercial company. I was pretty active in open source world, so we basically started looking around as to what is available at the time. There were not many projects like Asterisk, I think, was around, and we found SIP Express router, which was pretty early but quite promising. There was like probably like 5 modules at the time, and immediately it became apparent that we need to deal with NAT somehow. There was no NAT at SIP Express router at the time, so we started. Our first contribution was creating NAT helper module, which would allow to endpoints to communicate from behind the NAT. And while working on this module, it became apparent that while we can fix things that need to be fixed on the SIP side from NAT helper, we need some kind of external agent to help with the RTP, because as Daniel said, there is was no solution at the time in the standard itself. And so that's how RTPProxy began. It was pretty simple application. So we basically just created something very quickly, and yeah, basically everything rolled from there. Over the years, we also did some other projects in the area. So we organized 2 years ago, we organized 2 open SIPp events where we tested things like stir shaking, as well as better digest algorithms for authentication, which is RFC 8760. We also wrote, since 2015, I created like something we call VoIP tests. It's basically CI CD for testing various projects like Kamailio, SIPp B2BA, and others against latest version of RTPProxy, just to make sure that everything works. And it's been running since we're testing latest versions of Kamailio and so on with the latest version of RTPProxy. Now, often people ask why it takes so long to implement whatever, like feature XYZ in RTPProxy. Well, as I said, RTPProxy is not the only thing that kind of keeps me busy. So, like looking at what my time goes into over the years, that's kind of rough picture. And yeah, this is AI generated, and yeah, I actually like that. I did not ask for that fire, but it kind of came came automatically, pretty much. And so that's me. And yeah, we still care about RTPProxy. We still use it, and we still develop it. But you know, time is scarce. So yeah. But anyway, so whenever, in my opinion, whenever you develop something, you always have these trade-offs that you need to deal with. So there is always like usually like three things that you can focus on. You can focus on reliability, you can focus on performance, or you can focus on features. And our choice always with RTPProxy, at least, was always reliability, because for us, RTPProxy is just one relatively small component in the bigger system, and we obviously don't, but it's important component, so we don't want it to take the whole system down. So reliability is always a priority for us, and that's why we put quite a lot of effort in the last 7 years into creating a lot of unit tests, continuous integration pipelines, and so on, just to make sure that everything continues working smoothly. So now going to more technical section of my presentation. So this is kind of how first version of RTPProxy looked like. So we had just single thread, and we had a bunch of stuff that needs to be done. So we basically just looped around 200 times a second, doing this, that, and repeat. It worked okay for the time. I mean, the computers were much simpler by then, and so it was good for the time. But as time progressed, we started looking at how we can take it a little bit more into the future. And so starting with version 1.3, which we released in 2014, we started splitting it up into separate threads. So basically, first things we split out command handling into separate thread. There is login thread and thread for sending disconnect notifications when media goes away. And then with version 2.0, more of that followed. So basically, we split out all of the RTCP handling, playback, recording, and handling of session timeouts into separate thread. We also introduced a separate UDP sender thread, because from running like performance tests, it became pretty apparent that sending is pretty heavy, because UDP is not very performant. You need to do a lot of stuff in the kernel. So we split that, and we also introduced support for streaming TCP connections. So we needed another thread to handle accepting connections from TCP socket. And this is basically continuing with, we also created a separate thread for handling periodic tasks, various kinds of expiration of internal structures and so on. And again, continued with that with 2.2, moved timeouts handling code, session timeouts into separate thread. And so with 3.0, we did quite a lot of that as well. So now with 3.0, we split RTCP into separate thread. RTP and the recording runs in a single thread still. Playback is now separate thread as well, which helps with making sure that playback, whenever you play some prompts, they're not that playback does not interfere with RTP handling, normal RTP handling. There is also now separate thread for waking up. This is just basically to free the command processing thread from blocking when it needs to wake up, add some socket and so on. So basically this allows us to have command thread just focus on the tasks of handling commands. And it kind of pays off. So right now, according to our test, you can handle like several thousand commands per second per instance, and it's sufficient for any practical purposes. So now, what else have been done in between 2.2 and 3.0? We, as I mentioned before, we started quite heavy on continuous integration. So started with Travis 2015. It was one of the first systems that provided free continuous integration for open source projects. And then once Travis got acquired and they stopped providing free service to open source projects, we moved everything to GitHub Actions, and now it runs over there. So with 3.0, we have about 30-something tests covering pretty much all areas of RTPProxy functionality. We test forwarding, recording, playback, all the available modules. We also use some pretty advanced techniques to reach out to the hard-to-reach pieces of code, usually like error handling, stuff like that. We're able to test that as well, make sure that some unusual error would not take down RTPProxy. So that eventually resulted in pretty good code coverage. So we have about 91% code coverage. So pretty much any function you might be using in RTPProxy is tested automatically, and it helps tremendously with ongoing development because, as I mentioned, we don't have like huge time budget to work on RTPProxy. So by having this, it basically frees us from having to test everything manually. There is also a project called RTP Cluster, which I made some separate presentations in several occasions. And basically, this is the system that allows you to create kind of virtual RTPProxy out of several ones. And so instead of using functionality in Kamailio to spread traffic between several RTPProxy, you can use basically RTP cluster to mimic single RTPProxy and then distribute calls between how many instances you might have, like either running locally or in some cluster of machines. And that works pretty well. So we basically started with the Python version about 10 years ago, had it running in production for a few years, and eventually ran into like performance issue because it's Python, so it's not very performant. So 2 years ago, I think we written it in Golang, and it gives like pretty good performance, and we deployed it in production last year. Now, speaking about what's new in RTPProxy 3.0, We, as many requested or asked for many times, we implemented DTLS module, which allows to gateway between DTLS and normal RTP. Then we also replaced POL with ePOL, and this lifted restrictions, limitations on how many packets per second per session we can handle. So now with 3.0 you can handle video calls, all sorts of non-voice traffic, which requires much higher packet rate. As mentioned, playback is separate thread. And last but not least, we did quite a massive restructuring of forwarding logic to allow for pluggable translators. So we're starting with 3.0, we can have third party or built-in modules, but not part of the base system, actually injecting stuff into processing pipeline. So here we can have like, for example, DTLF module to insert some stuff into pipeline, or we can have some slogan module, and so on. This basically allows us to keep the core of RTPProxy pretty small and simple, but at the same time having those extra modules providing advanced functionality like, as mentioned, DTLS and transcoding. At the same time, we wanted to have existing functionality like playback or recording to seamlessly continue working. So if you have DTLS call, you probably want to decode it before you record it. Another way around, if you have DTLS session and you want to play back something, you want that to be automatically encrypted. So that works well. And then another change that we did as part of that, we're working on extending communication protocol. So basically the idea there is that we want, again, there are some proposals to implement DTLS by adding more parameters into existing commands. That does not work, does not scale very well because the code was already quite complicated and not easy to manage. So instead, we changed the protocol to make it a little bit more like language-like. So you can basically bunch up several commands, separate commands, so you can create session and then set up DTLS in separate kind of units. So we have this allows us to have quite clear separation, and error handling becomes much easier this way. So if some portion of that command chain fails, we can handle it properly instead of trying to figure out what exactly went wrong. And then another thing that was done on the protocol side, we implemented module-specific commands. So each module can provide its own kind of sub command interface, and then you issue commands, and that goes to that specific module. Again, this is to allow RTPProxy to be modular, so we don't have to have huge chunk of code, and each module can have its own specific interface. Now, speaking about DTLS modules specifically, another thing that we wanted to have is some built-in scalability, at least design it so it's scalable. Essentially, what RTPProxy allows you to do on the DTLS side, you can start multiple instances of DTLS module, and then you can use like call ID hashing or some other hashing to spread the load between those threads. This should allow people who handle a lot of DTLS traffic to have as many decryption encryption threads as they need. And speaking, it's already fully functional and tested. We support all scenarios that we think are relevant. So you can go from encrypted to unencrypted. You can also do other way around, obviously. And also what is important, you can also do from encrypted, like kind of B2B encryption. So you have encrypted stream on one end, you decrypt it. For example, you fork it or record it, and then you encrypt it on the other end and send it out. So this allows to have call recording, call forking working properly. I'll give you a little bit demo. It's not very polished, but let's see if it works. So here we have LinPhone. One side running on my desktop machine in Vancouver, and there is another virtual machine in Vancouver. There is another instance of LinPhone running. And here I can show you I have one LinPhone has okay. Yeah, so on this side we have encryption set to none. Encryption is mandatory, known. And the other side we have encryption DTLS. Encryption is mandatory. And so I can basically initiate call and have the video. I don't have video camera attached to the virtual machine, but you can see the video goes through. I'm not in the office as well. And here you can see RTPProxy actually running. So this is DTLS thread, this is all other threads. So everything works pretty okay. And this is not very powerful machine either. So this is like to call 5-10 years ago. So anyway. And then another thing that we did quite interesting for the 3.0 as we developed, as I mentioned, we're pretty heavy on continuous integration. One question was like, how do we test it? Like we developed this DTLS functionality, but writing tests for those would be a nightmare because you need to create a bunch of sessions and coordinate them. So just scripting it out would be pretty difficult. So what I did, I created a little domain-specific language which basically you specify your RTP proxies. You can have several, how to connect between them, and then you can script specific commands and use results of one command, previous command to generate the next one. So and here I have another small demo of how it works. So basically here we have 3 instances of RTPProxy running, and essentially we do like end-to-end tests. So we have one RTPProxy on one end, another proxy on other end, and another third RTPProxy in the middle, working as a forwarder. So and we record calls on both ends. And so here if I run my, I can show you how that script works. So basically we have 3 RTPProxy, then we set some variables, and we basically set up DTLS sessions with some parameters. And so here it's me running the script. Have another top. So here is also 3 RTPProxy running. You see there are two DTLS threads. So changing traffic, and it basically, the module also allows you to change parameters. So you see right now we're setting up DTLS on one leg only. Then we're enabling DTLS on the another leg, and you see immediately DTLS thread on the originating proxy comes live. And later, in like few seconds, it will shut down DTLS sessions and continue with like normal non-encrypted calls. This basically should allow for handling of free invites and so on. So you see DTLS is off now. And at the end, we make sure that everything checks out. So number of packets received on each side is matching up. We don't know what else, what other users might have, but if you have some kind of testing setup, might be something to look at as well. Another thing that we did for 3.0, we implemented OS-fuzzing. There is a project from Google which they provide infrastructure for open source projects to do automatic fuzzing. So we found it out about a year ago, and it was always interesting to, because security is always a concern, and also make sure that we don't break command parsing somehow unexpectedly. So we implemented fuzzing. Since everything is running in threads, we could basically just compile special version of RTPProxy and have fuzzer to inject commands into it. Works pretty well. Found quite not many, but quite a few bugs were found, and it helps to again to keep it working. And then the last thing that came out of this fuzzing, we kind of, if you look at this, we don't really need the main anymore. So basically what came out of this, what we call LibRTPProxy, and it's available in 3.0. And this basically allows you to embed RTPProxy into your own application. So if you have C application or some other language application which has C interface, you can basically run RTPProxy inside your application and communicate to it through the socket just internally. And that basically allows us to put eventually RTPProxy inside Kamailio, for example. So if you don't if you don't have a need for separate RTPProxy, you can run it inside of your Kamailio process. Yeah, basically work in progress, but keep watching. Should be available in a few months. So here is just a snapshot of how it runs. So here you see Kamailio main process. This one, then the RTPProxy threads running inside of Kamailio process, basically providing you the same functionality that you would have by running a separate process. And yeah, I'm pretty much done with my presentation. Some plans for the future work. Apparently Debian Ubuntu package is quite outdated, so we want to probably bring it up to 3.0. Next thing, obviously, we need some extensions on RTPProxy module to support DTLS. And as I said, the plan is to have transcoding module probably as part of 3.1. Now with this threaded architecture, we also should be looking probably at making scalability kind of automatic, because right now we rely on running enough RTPProxy processes manually. And last but not least, probably adding some TLS or DTLS for command channel for security would be nice. And that's it. I mean, conclusion here. I mean, yeah, give RTPProxy a try for your next project. It's not dead or abandoned, just slow progress. And as always, feedback, PRs or ideas are always welcome. Thank you.
Okay, thank you. So I had my question about packaging, but it was answered in the previous slide, updating in the Debian. And question here.
So that looks great. Thank you so much. And my question is, especially in terms of performance, how does it compare to RTP engine?
Oh yeah, for
Your
that
opinion.
I would recommend you to look at Flavio Goncavis from SIPp done quite interesting comparison last month. It's kind of interesting. Obviously, we cannot compete when kernel forwarding is enabled. So kernel forwarding is still like probably 3 times faster in RTP engine. But when you move everything to user land, RTPProxy is actually faster. And this is just for like playback. We have not tested with DTLS yet, but just for like call recording and playbacks and just forwarding, it's little bit faster.
Thank
and
you.
just on just to add to that, in raw numbers, we're looking at some like modern CPU we need about 2.5 cores per 1,000 channels in RTPProxy. Just
nice. Okay, let's approach one question, and then if you need to discuss more, Maksym will be around. Frank?
Hi. Do you have any experience if RTPProxy handles as well under virtualization as RTP engine does?
Yeah, it works cool. I mean, we're running, I would say 20% of our production deployments these days are going into AWS. And yeah, it works okay.
These days has to work to be alive. Okay, thank you, Maksym. Really appreciating. Again, here.
Thank you, Daniel, and thanks for having me. I'm really glad to be here after 5 years. It's about NG 112.911. So some news about NG 911.112. So what has happened in the last few years. I'm still with Frequentis, corporate research, and I'm also co-chair of the technical and operational committee of ENA, so the European Emergency Number Association. And DEC 112 is Deaf Emergency or Digital Emergency Calling. So that's a association in Austria. So it's a private initiative. We started to enhance accessibility to emergency services. And I have a few news about that as well. So that's actually using Kamailio in the back, so as emergency service routing proxy. Yeah, most exciting news first. So actually this initiative received an award at the last ENA conference in April. So it's the Next Generation Accessibility Award. Was very exciting for us to get that. And it just shows that, okay, with a nice idea and with new technology, you can get an ENA award. But more about this later. So why is NG 112 and NG 911 so important. So that's more the European approach or part of it. So you see that already started with changes in the European Electronic Communications Code in 2018. So they were requesting specific services for accessibility and also capabilities to route to the most appropriate PSAP, which means, for instance, in Austria, we have 9 federal states. And if you dial an emergency number in Vienna, you need to get connected to an emergency communication center in Vienna. Equivalent access for end users with disabilities to emergency services is also requested and also very important. So currently, you know, if you dial an emergency number, you get connected via voice-only service. Yeah, so some countries do have SMS as well. But with the new technology and with, let's say, multimedia broadband services, you can do much more. And this is also part of this changes in the communications code. Last but not least, the availability of network-based or handset-derived caller location. So that's also very important because I think everyone uses location-based services and the location is very well known, but not to emergency services. So that's someone doesn't really believe today that it's very difficult for them to get a dispatchable location, which means it must be that accurate that you can dispatch units and if they follow that location, then they are on site. Yeah, so they need to be there where they have to be. There were some changes and advances. So I think it's called in Europe the AML, Advanced Mobile Location Technology. So if you dial an emergency number, your phone sends either an SMS or an HTTP push in the back to a location hub, so-called location hub. And this one is then used for dispatching purposes as well. So it's a bit delayed because it's triggered if you dial a number, but that's the first step to get more and more accurate location to the PSAP. But in the future, and you will see that later on, it should also be possible that you immediately send your location with a call setup. So we've heard a little bit about the IMS this morning. And there are some elements in the IMS that take care of the location, and it's also the handset or the device itself that may provide location. That's actually what's being requested, and I think most important here is that we have some dates in the future, 2025. The European Accessibility Act requests that the network, so end-to-end IP, supports these accessibility services. So you need to have a connection that does more than just voice. So it's multimedia. They call it total conversation, which means you have means of text, video, and audio. And in 2027, this should be implemented also in the PSAPs, so the emergency communication centers. Short recap. I did that, I think, in the last 2 presentations here at Kamailio World, but it's always interesting to see how this evolves and what it does actually. Short recap on the next generation core services. So actually the orange boxes on the left side, and you have different originating networks. So you may have a mobile network, you have fixed network, you may have a web service provider, and common for them is that there is perhaps rolled out in countries in the future a kind of central service that does this kind of routing and mapping. So the main task of these elements is route emergency communication to the appropriate ECC, Emergency Communication Center. And this should work with any originating technology. So that's why there are standards around. So on the European side, we have this ETSI Tiez 103479 that actually describes the interfaces and the services itself. So just in short, we have this emergency co-routing function. So that's the GIS part of it that is doing the mapping. So it gets location information, it gets a service URN, which describes the need, the service you want to have, and then returns a SIPp URI that can be used for routing purposes at the ESRP level. And for that, there is a protocol. It's called Location to Service Translation, or LOST, which is actually what I've implemented in the LOST module that enhances then Kamailio, but more on that later. There's also an additional protocol. It's called HELT, HTTP-enabled location delivery. This helps to get a location from a location service by using an identity, for instance. So the identity can be the phone number, or can be a SIPp address, or can be an IP address, whatever. And we also have this location information service as part of the European specification. It's because it can act as this kind of location hub for AML, as I mentioned before. So I'm happy to share the presentation anyway, and I have included some links to the latest documents. So what's, I mean, that's not everything here listed, but what's the new features or new topics that were considered? So I think a big change, but can't you perhaps know more than I, a big change in the US in the NINA S3 document was a shift from XML-based architecture to REST and JSON, so just following this modern and best practices. So there were additional interfaces of web services defined, and in the first releases it was XML, and then now they're moving on with REST and JSON. There are still other interfaces that use XML, like the very important presence information data format location object, which is the container that provides either geolocation or a civic address. There's also some discussion about security going on in that community, and there were some implementations or requirements defined for steer shaken. So we did already some testing thanks to the SIPp ID module. And on the European part, we have, together with NINA, with the US, we've agreed on using common namespaces or namespace strings, for instance, for the call info header. So in the past, it was, actually, I don't know why, but it happened. Instead of emergency, the US document just stated URN:NINA, and the Europeans, we stated URN:INA. Yeah, but to just make it interoperable, and we did also some testing on that as well. We decided, okay, let's move on with more generic namespaces. So now we have them in the documents. And we also tested this interoperability cross-border, transatlantic, actually. Another very interesting part of the European specification, which we released a few months ago, is the handset location refresh using update. So if you're connected already to emergency communication center and the location changes, then there can be two methods used by the handset to update or to refresh actually the location. So that's not just for the routing then, it's actually for dispatching purposes. So if you're moving, then this would be two methods like the update or the re-invite to be used to update or refresh the location. So very important update within the dialog, because you need to be connected for these updates that end up at the control center. Again, there are some links to the documents itself. You will figure out that there's a huge difference. So the US document, I guess it's 600 pages. The European one is just 100 pages. And the 100 pages just means we do it more efficient. No? It means that we just reduce this to, let's say, the basic needs on the European side. So in the US, there's much more required because of, let's say, the layout of county-level PSAPs. So in Europe, you don't find that much county-level PSAPs. So it's more changing to actually state-level integrated PSAPs. So there's not everything actually needed, but the core services that I've shown at the beginning, they are the same in the interfaces as well. So the LOST module, just an update what it does. It actually uses the HTTP client part or module, and then it has two main interfaces. One is the health interface towards location information service, or server, and a lost interface towards an ECRF. It also does NAPTA, SRV, the DNS. So NAPTA is actually quite often used if you set up an hierarchy with this kind of lost services. So in short, it turns Kamailio into an ESRB with location-based routing capabilities. And yeah, I'm still maintaining it. So there were some new features and bug fixes I've added. So for instance, there was, a need to include the path element for lost recursion. So we did some tests in the last plug tests event or ICE event. So it showed that, okay, this needs to be done in order to make sure that there are no loops. And then, thanks to Sergey, SIPp asserted identity parsing did not really work. I mean, it worked in a let's say sunny environment, but if there are some crazy CPU arrays and I think it was the display name that caused this problem, then it did not really work. Yeah, the testing. So that's just an overview of what we did in 2021. So that was during pandemic. It was quite challenging because everyone was testing from at home. So there was NAT and NAT and NAT, and we still got audio through and even transatlantic. So I think you remember, Kent, that we had this crazy scenario. So we said, okay, let's initiate a call in the US, but provide a European location and see where it ends. And we were happy to receive this on the European side, thanks to this interworking of the emergency services IP networks, thanks to also having certificates in place. So that was also new. So actually the standard requires to support mutual authentication with TLS. And I think this was something a bit challenging at the beginning, but actually it worked quite well. And if you know how to install your certificates, then it's, I think, the major thing to do. The other things work quite well. We had also an ICE event. So in the US, it's an industry collaboration event. That was end of 2022. And we had a plug test event in Europe. So the ETSI course is plug tests, where we tested the NG112. And yeah, this is just a snapshot of how busy we are in setting up the infrastructure. So you have always an originating part, you have the core services, and you have to interconnect, and even you have to make sure that you get your remote participants connected. So there's some pre-testing necessary here to make sure that you have all the connectivity. We are planning further events. So end of this year, there will be another ICE event, ICE 10 in the US. And we also think of a new plug test event in Europe, September 2024. Yeah. So why do we need these core services again? So for instance, looking at the IMS and what the IMS does, if you dial an emergency number, is actually quite interesting. So you have your emergency IMS call setup procedure. Perhaps before you have the attachment that gets you the emergency numbers. If the device recognizes the emergency numbers, that's very important. Then it would be able to do this kind of setup. And then you have an element that's the emergency call session control function in the IMS that together with an LRF takes care of this routing tasks. So perhaps it just knows about an appearing entity or a point of interconnect with this kind of ESINet. So there's a border control function. It's something that you know actually from the IMS as well, so for secure peering. And then this ESRB and ECRF, they use the location information to route to the correct ECC. Very important here is that with this kind of multimedia, we get audio, video, and text if it's being implemented in the end device. And most important, you also get priority. So if you do an emergency call setup, it's not something that runs over the top. It's interworking with the IMS, and you receive a higher priority for emergency calling. The cool stuff with these core services and within ESINet is that you can also use it for other originating networks. Perhaps Bascom, if you're interested to join such a plug test event, you can peer with such an infrastructure and enable emergency calling on your end. The only thing you have to provide is a location. And a service URL. So that's the absolute minimum. And then depending on the features like audio, video, and text, I think there are also some requirements for sign language to have a certain codec in place. But I think that's not the challenging part. And actually, that's very good for interconnecting with campus solutions or with web service providers. We did test that already, so we had a nice partner in the last plug test event with a solution that interconnected to such an infrastructure. Very important, provides precise location, so that's very important for the PSAP. As I said before, for dispatching purposes, for routing purposes, it doesn't have to be that accurate, but for dispatching, it should be very accurate. Yeah. So some use cases are where you just provide a location by reference. This means that the PSAP or answering point can then repeat location using that reference. So if it has changed or if it gets more accurate after time, it would be possible for the PSAP to get the better location. And also for callback purposes, you need something that's routable. Well, why we got this nice award in Austria, it's enhancing the accessibility service. And we are operating this since 2019, so we're actually in the 5th year of operation. You can check this website for further information. So we are providing an application, we're providing the backend services, and we currently have 4 PSAPs in 4 different federal states. So the Notruf Niederösterreich, Emergency Services, Lower Austria, they provide services for the yellow part. So they're just forwarding then or forwarding information to the other federal states if there was this kind of chat. The light yellow ones are the 2 more to come. So we're currently talking about how to integrate with their systems. And then we have in the western part of Austria, Tyrol and Vorarlberg, who run their own emergency control centers and have integrated with our solution. So actually it's not integration with our solution, it's integration with the standard. Because we have standardized interfaces for that. And you also see that we have different numbers in Austria. So it's for the police, it's 112 and 133. And the police has a new system that covers whole of Austria, and they can internally route to any federal state. Currently, they accept all these text-based emergency calls in Burgenland. But as I said, they can simply switch over to another federal state. Yeah, the application itself, we have this well-known emergency numbers in Austria, and there's also a kind of testing feature implemented. So that's very important that people just can try it without requesting emergency help. So and there's also kind of silent emergency call, which means that you just press the button and you have a predefined text and it sends it to the police, and the police knows, okay, this was a silent request. So if you dispatch units, then they need to be careful if they enter the scene. So that's something that can be used for domestic violence, for instance. Using standard interfaces is always nice because, you get a lot of information that you can provide in the viewer. So here it's just an example for translation services, for instance. So we can easily integrate a translation service. So this is, I think, English and German. So if one just presses the button to translate, then it will be shown in the viewer. And even a fallback to SMS is also possible. So just selecting, you want to send back via SMS would help the PSIPp to get in touch with the person in need if there was no data bearer. Because the problem is, if you run over the top any application, you don't get the priorities and you don't get the quality of service. So you're just a usual user. Yeah, how do we operate? So actually it's SIPp over TLS and WebSocket. So the application uses WebSocket to connect to our application backend, which is Kamailio. Then we are peering with kind of border control function, which again is Kamailio with Spike. And then we have this internal ESINet where we differentiate between this core emergency service routing proxy that interfaces with our partner GridGears, which provides the ECRF, the mapping function. And then for the purpose of policy routing, we have kind of terminating ESRPs in place as well, and everything is containerized. So we have a hosting partner and we run everything using Docker Compose. And we also have, we are very transparent. We have a status monitoring which can be accessed so that you can see all the services and if they're up and running or if there's some issues. And yeah, very important because that happened already. We also get some feedback from the Emergency Communication Center regarding the states. So if they are available, and we use this in a so-called policy routing function, it's also part of the specification to make sure that we do not route to a PSIPp that is not available. So there is kind of rerouting, and the PSIPs that I attached know about this. And yeah, very important, all that was what was implemented is 100% compliant to this ETS 103.479. And there's another specification, it's ETS 103.698. It's this lightweight messaging protocol. So it's actually based on SIP message, SIP simple. Really easy to use, was the lowest common thing, or let's say easiest thing to implement also for the control room side. And it's also part of the specification because that's being used for non-human emergency calls to transport common alerting protocol content. So it interworks with all the elements. Yeah, well, this is what you've already seen. So that is to showcase how we integrate with a third party, actually. So the Tech 112 Association, we provide kind of API that can be used. Actually, it's open source to translate from a very simple REST API to the NG-based environment. And this is what I've shown in the dangerous demo. It's actually, okay, we get some information from Signal, a location, an identity, which is the telephone number, and we just translate this to the SIPp-based world and forward it to the ESINet and use all the means for routing purposes and get it to the PSIPp. So actually there was Kamailio involved. Yeah, that's it. Thanks a lot, and yeah, drop me a line, either Frequentis, INA, or Tech 112.
Okay, thank you. So if it's emergency, email to this Tech 112.
We're not responding to your emergencies, except it's kind of programming stuff. Yeah.
Okay, if it's business, INA.org. Okay, questions. Okay, you heard.
Yeah, thanks. I have a question. This lost module in this overall technology. Is it something that can help, for example, with the problem that our colleagues from PESCOM have, means getting all of their clients in the one trunk and whatever, or it's I'm something completely messing with?
Well, it depends. It can help, but it needs to be implemented. So I think there would be some, let's say, organization in Germany that runs these services, like Kamailio with the lost module, for instance, and then also peers with the PSAP itself. So then you have this kind of ESINet, and then PASCOM could be one of the originating network to provide emergency calls. So it could help, but it needs the infrastructure to be in place. So that's the challenging part of it, actually.
Yeah, okay, so actually I had a question similar in not with the one, but about the implementation. In this European Uniform Union, it's a lot of fragmentation. What's your feeling now? Is gonna emerge towards unified, like open protocol or open specification? So we kind of, or each country will still keep going for a long time with their own, in most of the cases, private infrastructure.
There are a few factors, I guess, that need to be considered. So at the one hand, I think with the move towards, let's say, broadband services in the MNO side, you will have also a move towards IMS, which means you need another way to route to PSAP. So either you do this in the IMS or you do it in a kind of ESINet. And I think that would be the trigger for implementing the right infrastructure. And there are not that much options. Yeah? So you have this specification available, and you can just implement it or use it as it is. And I think that will be the common denominator. So we say, okay, if I have different originating service providers like web service providers, MNOs, and I have still the same need to get connected to the right PSAP, I need something like this in place. And I currently see some moves in Europe because of this European Accessibility Act that I think will lead to that at the end.
Okay. Okay, thank you. So not soon, maybe in 10 years, but yeah, we'll be more integrated between the...
It's 2027. You see?
Okay. Thank you, Wolfgang. Thank you so much.
No, thank you again thank you for having me once more at this event. I really love coming back, especially after this long hiatus. So yeah, this presentation will cover my attempts to try and experiment and prototype a bit with real-time text, which is one of the key components that are going to be part of NGM emergency services in the future. And of course, I wanted to figure out how to gateway all that to WebRTC in the first place. So just a very few words about me. So I come from Napoli, and I got my PhD there, and together with some colleagues, I co-founded a small company called Miteco, and most of you may know me as the main author of Janus, and there you can find some links to get in touch or just check some of my hobbies over there. And as a company, we are a small company, about 5 or 6 developers. We do a few things mostly related to standardization and open source. So that's why we are very interested in SIPp, RTP, WebRTC, this kind of technologies. So anything that involves real-time multimedia applications is something that we do. And we do several things, and I stress again that we are based in Naples, which this is usually where I put a nice picture of Naples from above to see what a beautiful city this is. But this time I had to put this picture instead, mostly because we've been waiting for this for exactly 33 years. So 33 years ago we won the last league, and it was with Maradona, so it was a long time ago. And we've been celebrating non-stop for a month, and I would like to tell you that we are exaggerating, but we're really not. So every day we've been celebrating a lot. So I still am, as you can see. So coming back to the real topic of the conversation, my focus again will be mostly on real-time text, which is a technology that was specifically developed for the hearing impaired. And it was originally conceived in the 60s. It had a few different names, as we'll see later. And basically the idea was that you had some specific devices that had a small screen, a modem to communicate, and a keyboard to actually insert whatever you wanted to type. The messages would be exchanged back and forth using electric signals, and then it would take advantage of the phone line, which was the only way to actually do anything like this at the time for the masses, to actually deliver these messages. And it was very widely used in emergency services some time ago. For instance, it was used by 911 operators to engage with people that could not actually talk on the phone. And most importantly, since it needed to also work in power failure modes, this device had its own batteries. And again, since it used the phone line, it really didn't matter if the power went away. And the device looked a bit like this. So now it may not look like something extraordinary to us because we are used to much better devices, but at the time it was a very big deal. And again, there are several different denominations for this technology, mostly because they also differed a bit. So I'm not really an expert to tell you what the differences were, but I've seen TDD and TDY, for instance, used pretty much interchangeably for the technology. I mean, in general, I may be wrong again, so please correct me if I'm wrong later. So there were some inherent limitations in there. So for instance, it was half duplex, which is why, for instance, whenever you wanted to say something, you had to explicitly, for instance, add the GA go ahead at the end of the sentence so that you could let the other person chime in. I mean, this means that being half duplex, it really couldn't be interrupted, but technically you could, but then you could get garbled output. It would mostly use a limited set of characters because, for instance, one specific instance I've seen used Baudot, which meant 5 bits to actually encode the characters plus one end and one end bit, so 7 bits in total, which didn't really allow you to cover the whole alphabet in most cases, which meant that you had some special codes to switch the set of characters that you wanted to use. No specific handshake, meaning that once the call was up, you really didn't have something that explicitly told you, okay, now we're ready to go. So it was a bit tricky in that sense, and no error correction either. And again, it required some specific device. And I mean, I'm just highlighting this not to really weigh down on this technology because it was great, but it does have some limitations in today's world. That's the main topic. And so Wolfgang already covered this, so I will not touch this again. But in general, the legacy emergency services mostly relied on the PSTN to do their job. Now we're trying to do something on using the internet instead, and so richer protocols like location and other things to involve richer media as well. And I'll be focusing mostly on real-time text. And again, I'm not an expert on the framework per se, but I wanted to really focus on the protocol aspects of real-time text and check whether or not how that worked within the context of SIPp and what work would be needed to gateway that part to WebRTC as well. And as far as the real-time text is concerned, to do pretty much the same thing that those devices did on top of over IP, basically a specification called T140 was developed by the ITU, and it also allowed for real-time editing. So for instance, you've seen in the demo that I did before, I mistyped something, I went back, corrected the test, and wrote it again. That's because T140 included, for instance, a special code for backspace. So I would send the character that would actually be a backspace, and the other device would correct whatever I was typing in real time as part of that. And of course, in order to have it used and within the context of, for instance, a SIPp session, they needed T140 to be able to be transported over RTP so that it could be treated pretty much as we treat audio and video every day. And there is a specific RFC that explains how you can actually encode T140 as part of RTP packets, so how you actually transport those over RTP packets. And the specification also mentions that you can make use of RED, which was originally conceived for audio streams, to actually implement redundancy, which, as we'll see, is actually quite important if you want to implement some form of error correction or reliability of the stream so that you don't miss anything in transition. And T140 in general is not a very complex specification. So it basically, that's the link if you want to actually see the specification itself. It's basically based on the concept of blocks, let's say. So you have a set of characters or again, special codes like enter or backspace that you may or may not want to group together. And then you send these packets typically as soon as possible, or also maybe taking into account some trade-off between overhead and latency, because of course you can, as soon as I type something, I can send an RTP packet out, but that would also mean a lot of overhead, because at the very least an RTP packet is 12 bytes. If I'm just sending a single byte of payload, I'm wasting a lot of bytes just to send that piece of information, especially if I'm typing fast. It may make sense, for instance, to wait, for instance, for 100, 200, 300 milliseconds for the user to type a few things and then send them in batch instead. From a user experience, it doesn't change much because you still see text appearing in real time. It just doesn't happen right away. It may happen a bit in batches. And I mean, there are some guidelines, but at the end of the day, it's really a matter of the trade-off between overhead and latency that you want there, because the more you buffer, the later people will see what you're typing on the other hand. That's the gist of it. And it uses UTF-8 for characters, including those special actions that I mentioned. For instance, byte order mark, which is helpful whenever endianness is a concern. And when it comes to RTP, it's actually fairly straightforward, because you just put the T140 blocks that you have encoded as the payload of the RTP packet. Of course, setting the payload type accordingly, because as we'll see, this is something that you negotiate via SDP pretty much as you do with audio and video. The timestamp will increase as if the sampling rate is 1000 Hertz, so that's always used as the reference there. And as I mentioned, RED is quite important because it allows you to recover from potential losses, which may not be that much of an issue, for instance, with audio, where you can possibly recover. Sometimes with text, it may be problematic because the text that we may be missing may, for instance, be a code rather than some text, and so something quite important. And so if you don't use RED, this means that if you lose packet 8 in transition, then you just have 7 and 9, you don't know what happened in the middle, and that's a problem. With RED, the idea is that each packet does not only contain the current block that you are sending, but also contains 1 or even 2 of the blocks that you've sent before. And that's basically what RED does. So it adds redundancy by just sending the same information multiple times. So for instance, packet 7 will contain also the payload that 6 and 5 had. 8 will do the same with 7 and 6 and again. And so if we lose packet 8 again, we are now able to still recover the main content of packet 8 by the next redundancy packet that we receive after that, which is a powerful functionality and definitely helpful for real-time text in this context. Of course, the way RTP looks when you involve redundancy is a bit different, and this is specified in the RED RFC. Basically, the payload is not just the T140 payload that we were sending before. The payload type changes as well, because RED, as we'll see, has its own payload type, because it looks like a separate codec, even if it really isn't. Timestamp will be the one of primary encoding, so it will still be 1000. But then, depending on how many generations you have of the RED packet, you may have 1 or 2 redundant packets with their own block lengths and payloads, block lengths, and eventually at the end you have all the different payloads one after the other, and you can demultiplex them by just looking at the block lengths inside RED. And of course, since this is RTP, it means that we can negotiate it with SDP, which means we can use it in SIPp as well. And the way that we negotiate it is by basically negotiating a text M line. So rather than the usual M equals audio, M equals video you may be used to, you need an M equals text instead. And specifically, T140 needs to be advertised in the RTP map. And we mentioned that the timestamp must be 1000, the reference for timestamp, the sampling rate, which means we end up with something like this. So we end up with a text M line, is still RTP, an RTP map with T140 and 1000. In this case, the payload type for T140 is 98, we may want to offer redundancy as well, which is why red is here with the same sampling rate, with a different payload type. And the way basically by which we associate them together is by an additional FNTP line that basically associates the payload type of red, which is 100, and the payload type of T140, that is 98. And in this case, if I recall correctly, it's 3 different numbers over there, by just specifying that you will have 2 different generations for red. So you will have the primary data and 2 redundant packets in general. And of course, so far I've been talking about how it works with SIPp and RTP and so on and so forth, but I'm mostly involved with WebRTC work in general. And so I was really interested in checking whether or not WebRTC could actually be used in such a context. And of course, you probably already know that WebRTC doesn't make a heavy usage of VoIP technologies in the first place. It does make use of SDP, it does make use of RTP, or RTCP, and so on. But all of those protocols are pretty much used on steroids, as we usually joke. So there's a lot of additional stuff that regular SIPp endpoints usually don't really understand or use. So for instance, RTP uses detail SRTP, which is not typically used there. Most importantly, though, the WebRTC specification only supports M equals audio and M equals video. So it only specifies how to use audio and video as media. It doesn't have any knowledge or awareness about M equals text at all, which means that out of the box, WebRTC cannot use the existing specification of real-time text. What it does have, though, is an M equals application M line that can be used for data channels instead. And data channels are a very effective technology that basically encapsulates SCTP over DTLS to basically exchange any form of data that you may want to exchange, also possibly using different channels in parallel within the context of the same session. And starting from this, actually, the ITF came up with a specification to try and implement a sort of bridging technology there. So a way to have those T140 blocks that we've seen exchanged via RTP in SIPp over data channels instead. And so that's the link to the specification if you're curious about it. And again, very simply, it specifies how you can actually send T140 frames over data channels rather than RTP, which of course gets you rid of the need to have red in place in the first place, because red you don't need anymore, because data channels can be configured to be ordered and reliable, which means that you already have a way to enforce a reliability of the real-time text stream, even though it is real-time. And again, you can also use different labels for specific RTT sessions, which means that over the same data channel, you can have multiple real-time conversations at the same time if you wanted. And so it's a powerful feature if needed. Of course, this is a completely different technology than the one that we've introduced before, which means that you do need some sort of gatewaying in place if you want a WebRTC device implementing this to be able to talk to a SIPp endpoint implementing the existing version of T140 over RTP instead, which is exactly what I tried to do with Janus in the first place. And this is an example of how the current specification of that RFC describes how you can negotiate stuff. And in practice, it's not really implemented like this because, for instance, you can see many attributes that WebRTC doesn't currently support. So browsers don't know what to do with, for instance, DCM attribute, DCSA, these sort of things. So these are all attributes that the RFC specifies that can be useful for negotiating additional features of T140, but that browsers don't really support. So this really intrigued me, and I wanted to figure out how to prototype some sort of a gateway of sorts. And I did that a few years ago in a pull request that I closed at the time, and I'll explain why in a few minutes. I also documented all this into a detailed blog post if you want to read this on your own time. And then I revived the effort just recently on the latest version of Janus. So if you want to test all these, you can refer to the third link over there to actually use it in practice. And the idea was to use the SIPp plugin in Janus as the actual gateway to basically act as an intermediary between the WebRTC world and the SIPp world, as it already does for audio and video, but this time for text as well. So on one side, on the SIPp side, the SIPp plugin would take care of negotiating that M equals text M line to negotiate T140 the SIPp way. And whenever that happens on the SIPp side, use data channels on the WebRTC side instead. And same thing on the way around, which means that we do rewrite the SDP back and forth when Janus sits in the middle over there. And once that happens, T140 blocks are just bridged exactly as they are, because those don't change depending on the transport. They are exactly the same whether you use RTP or data channels. So whatever I receive via RTP as a T100 block, I send via data channel on the other side, and likewise, same thing on the other end, which means that any form of pacing, as the discussion that we made before about overhead versus latency, is something that is up to the client side. So it's up to them to decide how many blocks they want to send to Janus, and then Janus will send those blocks via RTP on the other end. And of course, RED is supported on the SIPp side if needed. So if it is negotiated, it will be used on that side as well. And basically, from a visual perspective, it looks a bit like this. So this is the way that the SIPp plugin works in Janus, and this may be familiar if you follow the previous presentations I made at Kamailio World. But in general, the Janus SIPp plugin acts as a collection of SIPp endpoints on behalf of WebRTC users. So you never see SIPp here. SIPp is originated by the SIPp plugin in order to communicate with infrastructures. And this typically means just gatewaying RTP and DTLS's RTP media. But for T140, it means also gatewaying the SDP to allow different kind of negotiations for T140, depending on where we're doing things. So again, mtext on the SIPp side, data channels on the WebRTC side instead. Which means that an SDP for the SIPp RTT stuff that looks like this would be translated in an SDP that looks like this on the WebRTC side. So M equals text on one side with red, and data channel negotiation on the other side instead, and then the client side takes care of setting up the channels to exchange actual packets. And I actually prototyped these. I mean, these are screenshots that date back from when I wrote that blog post. So at the time, I only had access to TipCon1 as a very simple SIPp RTT implementation. And so I used that to establish a session with the browser implementing the WebRTC side of things. Pretty much the same thing that I did in my dangerous demo before, but instead of a dumb video game, I had an actual real-time text implementation on the other side to do things. And things effectively seem to work as expected, because, for instance, everything that I was writing from the Janus side would appear in real time in this box over here. And likewise, the WebRTC user would, in its own much uglier user interface, would see the same thing. So you would be able to see text appearing in real time, and you would be able to type your own text in real time as well. And of course, I did some captures as well, just to make sure that everything was working as expected. And so I did some captures that included both T140 and RED encoded payload as well. Which brings me to the conclusion. So what's next at this point? So first of all, I really wanted to revive that effort. And I mentioned how I actually started working on this a few years ago. But basically, I got little to no feedback at all. It really didn't seem to interest anybody. So I also tried to find other real-time text SIPp endpoints to interact with, but the only one I could find was that very old and ugly TipCon1. And I never found any other endpoint, especially in the open source space, that I could use to interact with. And so I really don't know if this actually works as it should in the way real-time text works today, for instance. That's something that I really want to do. But I mean, I decided to revive the effort anyway and talk about it here, mostly because I assumed that there would be people interested about this effort in this space. If that doesn't happen, I'll close it again, so not a big deal for me. I did it already. And mainly, I decided to do this also because I had also moved a few things in Janus in the first place. So for instance, RED is now supported natively in the Janus core because we support it for audio packets as well, which means that I could simplify the original patch where I had a brand new implementation of RED in the first place, which was not needed anymore. I should write a prettier user interface that the one that you've seen in the demo, but that one can wait much longer. And again, what I'm really interested in is being able to test these with other endpoints rather than that very old endpoint, which provided me with some functional testing and some help. So I know that it should work, but I also know that TipCon is, I don't know, 10, 20, 50, 20 years old. I have no idea. It's very old. So I really would like to test it with endpoints that implement real-time text today to see if it actually fits the bill, especially because I believe that this is an important technology, and being able to use WebRTC as part of an effort of this sort could actually be useful in several different use cases. And that's basically all. So I hope I'm on time and there's time for some questions.
Thank you. Questions? Yeah.
Maybe I missed something, but when you showed it, for example, for this game with the phone, I haven't seen the real time. Means that when you're typing something and you're just send and it's sent immediately. So I didn't see it something like a.
Yeah, maybe it wasn't immediately visible because of the small screen, but actually while I was typing, for instance, it was more visible when I used the live debug mode. So when I enabled the debug mode in the clients, basically a small thing appeared over there, which is where I usually type commands, Lua commands in real time to trigger a specific action. And what was happening was that when I was typing stuff in the browser, while I was typing, they were appearing in the game as well. So the enter is just there to basically say, I finalized this line. And this is a special code that endpoints just use to format things a bit differently. So rather than just updating the current line, it's like, okay, /n, /share, this is a new line, let's start from here. Which means that the backspace, I think it shouldn't impact previous lines as well. I'm not sure exactly how that works. But it means that there is a new line now there. The enter is definitely not the way by which you say, okay, now send this. Otherwise, it would just be regular instant messaging. The idea is that as you type, you may buffer a bit, you may not buffer at all, but you're sending packets as you type. That's the main point of real-time text.
Okay.
How it will work if you don't type anything? So you will send an empty package like a comfort noise or something like this.
I'm sorry, how would it work without?
Without any action from user. If you don't type in anything, you just send like empty packages or something like comfort noise, or just don't send anything. So.
I think you either you don't send anything, or I'm maybe Wolfgang may correct me on this, but I think I've seen TipCon maybe sends the byte order macro on a regular basis, possibly just to keep it alive, but I think you just don't send anything at all. I mean, you may be sending something just to clarify that the session is still alive, sequence number are going on, and so on and so forth. But I'm not familiar with the details of this specification. And this is, again, yet another reason why I would really love to see how a real endpoint works, because I just worked by reverse engineering what I saw and tried to figure out the missing bits in between.
I have not a question, but I would like to invite you to join an interoperability test event in Europe because actually we have the same issues like you. There are not that much implementations around for testing purposes. So we every time invite participants to also provide real-time text implementations. But we don't do that much testing at the end then, so it would be great if you join. And to the previous question, actually, I have also no details, but
okay, so
we're it out in one of the test sessions.
Okay, thank you very much.
Okay, one more question back there. And
I just wanted to ask, I mean, the good old technology called telex comes to mind. And I mean, telex can be transmitted over different media. I mean, and the advantage was that telex was also a legal form of documentation. So if you were chatting with someone, you could make a contract right there in telex, and you had a record of that. So it was a great advantage for commercial business. Is there some connection to that? Couldn't one implement telex over this technology?
Yeah, to be honest, I'm not familiar with that technology, so that didn't. I mean, when I started doing my searches, I just, especially when next generation services they'd make mention of real-time text. That's what I started focusing on. Also because my effort mostly revolved around the IETF efforts, and being real-time text an actual IETF documentation, it made it easier for me to start investigate that, also because that seemed to be the basis for what next generation services were going to implement, and that's what I started working on. And also considering that the WebRTC side of things also started from that technology in the first place. So For instance, I don't know if Telex is a standard as well, or how much deployed it is, and how it fits within the context of SIPp and other things. In general, if you can use it within SIPp and SDP, and in general, my guess is that it should be able to gateway it pretty much the same way as we did for T140, mostly because data channels are completely agnostic with respect to what you're actually exchanging back and forth. It's actually up to the endpoints to agree what they are actually exchanging so that they can interpret it. So it really boils down to how you can use it within the framework of a standard communication like SIPp and SDP in general, and whether or not it's easy enough to gateway.
Okay. Okay. David, you prepare yourself. And one more question, Italian to Italian, yeah, Napoli versus AC Milan, or I don't know.
Veneto.
No, it's not just a question, but just a comment. It was verified in the documentation. And the data channels in release 18 is going to be based on WebRTC. In release 18 for mobile network, the data channel is going to be handled by WebRTC.
Okay.
So just to know this.
No, okay. In general, I assume that data channels are typically not widely available in SIPp endpoints themselves, which is why I usually refer to it as a WebRTC technology. But if it is available in SIPp as well, the more implementations, the better.
In the future, release 18. The SIPp for mobile networks, not the classic. Okay, so we have now David Duffett. The free switch project, a lot involving the community management. But yeah, he's now guiding us how we could express ourselves better, how we could transmit what we want to say better to the audience. And let's give the floor to David so we can learn that. Thank you, David, for coming.
Thank you. Thank you very much, Daniel. Now, everybody's been sat down for quite a while, so I'm just going to invite you to stand up for just a couple of seconds. So do stand up. Turn to the person next to you and say, I'm really looking forward to this. Okay, you can sit down again now. I just thought we needed to refresh the energy in the room a bit, and I'm aware that we've got a coffee break coming up, and so what I want to do is just have some fun, but fun with a serious intent, all about helping geeks to speak between now and our break. So why am I doing this? As Daniel mentioned, I've had involvement with Asterisk, with SignalWire, and really enjoyed that. But what I've found is when I've kind of done a little bit of navel gazing, looked inwardly, that my heart is with the geeks, and I want to help geeks. Because in all of the companies I worked, like with Digium for Asterisk and SignalWire, there's a lot of geeks around. And very often, they got their corner of the office, maybe with the lights down a little bit lower for their green screens and things like that. Maybe they got their boss buying them pizza on a Friday. But in a lot of cases, they were not as well respected or rewarded as this guy, the sales guy round the corner. Now, of course, Ron Burgundy himself is not a sales guy. He's an anchor man. But you get the idea. The expense BMW. The trips to Florida when you hit your targets and all that kind of stuff. And I thought, well, hang on a minute. These geeks are making and supporting the products, and yet they're not as well respected, rewarded, or recognised as the sales guy around the corner. And what I didn't want to do is take anything at all away from the salespeople, because that's an amazing skill in and of itself. But what I wanted to do was to help geeks be more, do more, and have more success, whatever their own definition of success was. And so what I found is going around the world and speaking at different conferences, delivering training, and I've been speaking at conferences for more than 20 years. You can tell there's a little bit of grey hair here. What I determined was that geeks need help in the world of speaking. Not to other geeks, because there's kind of geek to geek thing that goes on there, but to other people outside. And so having seen and given a lot of presentations, I thought I could help. By the way, in 2013, I was named a friend of the Kamailio project. Well, actually, I was named in 2014, but for 2013. And that also means that Daniel and Ramona and the team have been doing these conferences for 10 years. So let's give them a little bit of a round of applause for doing those things. And while we're talking about community, some of you may know Atle. It looks like Atle, but it's pronounced Atle. And Atle wanted to say hello to everybody because he can't be here this year. So Atle says hello. Anyway, let's move on to the agenda. What I wanted to do was look at the problem. The problem is the geek communication and presentation skills. And the troubles that arrive, the symptoms, if you like, of that problem. And it's that opportunities are lost. Jobs may be missed out on. Promotions may not be obtained. Funding might not be obtained. A sale for your product might not happen. And so the solution to that problem, I believe, is to set about massively improving geeks' communication skills. So that's what I'd like to cover today. How does that sound? Is that all right? Okay, in that case, I'll feel I can carry on. But before I do, I've got an educational video for you. Now, Sebastian mentioned it was a bit like a class reunion. And you remember in school when the teacher used to play a video? Well, I've got a video for you. I'm going to attempt to get it with the 4-finger move. There it is. And I'm going to play it for you. I think you're going to have to stay quiet because it's going to come through the speakers here and they're not terribly loud. But here we go.
I'm a nerd. I'm not a geek. I am a nerd. And what's the difference? You're probably asking, what's the difference? Actually, I have a Venn diagram to show you the difference. I'm one of the few comics working in Venn diagrams. It takes three things to be a nerd. You have to be smart, socially awkward, and obsessed. All three of those things, and you are, in fact, a nerd.
Right, actually.
Geeks, on the other hand, they really are just smart and obsessed, because they're like into comic books, comic book geeks, Star Trek geeks. They get dressed up, they do cosplay, they go out and they intermingle. Not nerds. We stay at home and don't do anything. We text and email. That's about it. Now, if you're smart and socially awkward, you're a dork. And nobody wants to be a dork. So if you're a dork, you just get obsessed and you move into the nerd region. And if you're socially awkward and obsessed, you're a stalker.
That's dangerous territory. That's the stay.
What's amazing is how close those four things are, really. A short walk between these.
There we go. I just wanted to get that out of the way at the early stage of the presentation because fortunately it applies to all four categories. And I'd like to make this a highly participative session. And so I brought some English chocolates along to encourage participation. And so what I want to explain is the nub of the problem. Now, you might have seen this as a bell curve or a standard deviation or even a normal distribution. But what it says is something that statistically cannot be argued with. And that is when you look at all the presentations that there are out there that are delivered every day around the world, and there's millions of them. There's actually a figure that goes back to the early 2000s that talks about 30 million a day. But I don't know exactly how many there are. But what I do know is most of them statistically and obviously are around average. That's inarguable, isn't it? But down at the bottom here, as we tend towards very poor presentations, we have this area that I refer to as BCP. Now, BCP stands for buttock clenchingly poor presentations. The kind of presentations that are so bad that they make you feel uncomfortable in your seat. And if you've ever seen somebody walking out of a presentation like this, you may have thought that maybe they needed a bathroom break, but it could be that they were watching a presentation that was so poor, it was buttock clenchingly poor. Up at the other end, of course, we've got SOG, which is standout great, or even standing ovation great. These are presentations that are so good that people are absolutely riveted to them. They can't wait to do whatever the presentation is telling them to do, whether it's buy something, change their behavior, adopt a new work process, whatever it might be. They just can't wait. Unfortunately, when we look at that lower half of the presentations, the ones tending towards buttock clenchingly poor, there is a disproportionate number of geeks represented in that particular area. So geeks are disproportionately represented in the poor presentation section. So why is this a problem? Well, first of all, what I want to say is in an environment like this, it's not a problem. because this is geek to geek territory. And so it doesn't matter so much because there's a huge amount of respect and admiration and rapport between the presenter and the audience in a geek to geek kind of situation. However, when we get out into the outside world, what we find is that often the decision makers, that's the person giving the job, the interviewer, could be the person with the money for the funding, could be the person that wants to buy your product. These are generally, not always, but generally less technical. And so this is the point of this presentation, is to arm you to get out there in front of less technical people and to make a positive difference with your presentations. Here's the phrase, knowing your stuff is not enough. Because unless you can convey your stuff in a way that these less technical, purse-holding people can appreciate, understand, and take action on, you're not going to make the progress that you need to. And the last thing that I want is for geeks to miss out on opportunities. That could be the opportunity to even attend a conference because you haven't sold it properly to your boss. Obviously, you all managed to make it here, so that's great. But then there's ComCon, there's ClueCon, and I'll be at both of those, by the way. Look forward to seeing you all there. And so what happens is when geeks miss out, the money does not flow, whether it's your salary through a promotion, whether it's selling a product or a service. So it's not good for you, your company, or even your open source project, because of course, you know, money lubricates all of this stuff that we're involved in. But here's the truth. You don't have to be a mile in front to be a winner, do you? You just have to be an inch or a centimetre in front. And so, if you're prepared to take what I'm going to go through in these presentations and actually implement it, that will put you in the small percentage of people that will actually be out in front, and you'll be noticeable by your excellent presentations. Because the better you communicate, the more you're going to generate. And when I say the more you're going to generate, you can apply that in any dimension you want. The more interest you're going to generate in your product or service, the more sales you're going to generate of whatever it is you might want to sell, the more activity you're going to generate in your open source project. It's all about communication. And what I've done is over the years of giving presentations and seeing presentations and even choosing presentations for things like Astricon, I've boiled it all down to 7 power presenting protocols that can be followed to give an excellent presentation. The first one of those is the purpose. It's talking about why you're giving the presentation in the first place. The next is the plan, how you're going to plan your presentation to take maximum advantage of the attention span of your audience and how to file things away in their minds so that they take action. Then we talk about preferences and the way different people come to things and how we need to be careful not to do our own standard thing because it might not be applicable for our audience. Then we've got practice. And I'm going to go through these in a little bit more detail soon. And of course, practice is a very important thing. Then we've got participation, also of vital importance to truly engage your audience. Then there's the performance, actually getting out in front of people. Notice that the first 5 protocols were before you ever get in front of an audience. So there's a lot of preparation. Now you hear, don't you, people talking about the fear of public speaking. Oh, it's a terrible fear, public speaking. Let me submit this to you, that a lot of that fear is actually the thought of being ill prepared in front of people. And the more preparation you can do, the more comfortable you're going to feel. I'm not saying it's going to eradicate everything, but it will certainly disappear a large percentage of it. And then the last one is post-event. What do you do after the presentation? So what I'd like to do is go through those 7 in a little bit more detail and throw out some lovely English chocolate for people that participate. So the first thing is thinking about the purpose of the presentation. And let me ask you this. If your boss says to you, I'd like you to make a presentation, what's the first thing you think about, if you're honest? Go ahead, sir. Achieve something. I like that. I like that. That's good. But, you know, really, truly, when the boss says, I want you to do this presentation next week, what do you tend to do? Sorry? I like that one, Fred. There's a crunchy in it for you. I'm still not getting to the truth, I don't think. Yes, sir? Well, it's another valid answer, but it's still not the... What do you generally do? Well, that's nice. Where was that coming from? Right, I'm gonna try this, Sandro, but I can't. Oh, sorry. Look, let me submit. I'm going to get to it. What you tend to do is you think, well, I've got this stack of slides on my laptop, and if I just move this couple around and delete that one or hide that one and move this one, I'll probably be all right. Am I right? Yeah, you need to. This assumes that you've got some slides before. Yeah, I'm going to give you a chocolate just for assuming that you have to have a slide deck first. But that's what tends to happen. And of course, the slides that you've got are not the presentation, they're the visual aids for a presentation. And yet our mind goes to that. And so what I'm going to suggest is that when you're asked to do a presentation, you actually take a step back. You keep your laptop firmly closed and you think about why you're doing this presentation. And you think about it at a deep level. What am I trying to achieve inside the presentation? As an example, teaching people the 5 best things about this new product or service. But then what is the company trying to achieve beyond that? And as an example, it might be to reduce the number of technical support calls that are received in the first few months of this product's life. So we try and think about these. This doesn't need to be a weighty document. This can be a couple of paragraphs or even a single paragraph on an email. Depends the level of detail that you want to get to. But what you're going to do is get this and have it between you, the person that's asked to do the presentation, the person that asked you to do the presentation, that I tend to refer to as the sponsor. Not always one. If it's a conference speech, perhaps it's the conference organizer that will be the sponsor. And of course, the audience. Very important that you consult all of these. And it's an iterative process. What you do is you go round until everybody's happy with this short description of what you're going to achieve. And then everybody is in the same page. And so in Venn diagrams terms, what your audience wants and what you're going to deliver are kind of properly overlapping. That's what we're looking for. Now, you might say to me, hang on, David, I'm not sure that you can always get to your audience ahead of time. And a conference like this is a perfect example. Nobody knew exactly who was going to be here for their individual presentations. And so did you notice when I went through the agenda, I said, is that all right with you? And most people kind of nodded politely and said, yes. That was me consulting with you to make sure that what I was going to go through was be good enough. Because it's important that we're all on the same page. But in a lot of circumstances, especially if it's a potential client visit, you can get in touch with the people ahead of time and say, this is what I'm thinking to do. It's just in this couple of paragraphs. How does that sound to you? How's it going to be? So you arrive at an understood and, most importantly, an agreed purpose. The next thing is the planning. And people's attention span works like this. It's always very high at the beginning of something, and then it can wane if you're not careful, and then it comes back up at the other end. This is why in an ad break on the TV, the first ad and the last ad are more expensive than the rest. If you want those slots, you have to pay more for them. There's other things that we can do in the middle of a presentation to up the audience's attention and keep things a bit lively. But what we can't do is we can't actually stray away from the fact that the beginning and the end are the most important parts. What usually happens at the end of a presentation? Q&A, a prime area where things could go a bit awry. Somebody might ask a question that's a bit off-piste or something that's a bit irrelevant. So here's just one word of advice. Never finish your presentations with a Q&A. Now, different, as I said, for an audience like this. But when you're in a situation where you want people to take away an important message, that needs to be at the beginning and the end. And so by all means, have Q&A, but have it before the end. So that the thing that you leave people with is the key message that you want them to get. Who was the one that said Q&A, by the way? Right, okay, I'm going to try my hardest here. Just a bit of fun. Okay, so what we've got to do is with this knowledge, we've got to construct a map of the presentation that effectively tells us what we're going to do near the beginning and near the end and the way we're going to organise things in the middle to file them away into people's memories so that they will take action. Now, I don't have the opportunity time-wise to go through all of that, but all I want to say is it's possible to have a map so that you're not just randomly throwing things down on a slide, but you've really got a plan that's actually going to work on people and work with people and the way that they pay attention to things so that you're going to lock in the key information in their minds. Here's the next thing, it's preferences. We all have preferences of one sort or another. In this particular case, I'm talking about learning styles. And let me ask for some more participation. Imagine if you've got a brand new thing. Could be a digital video recorder, could be a watch, could be a coffee maker. Hands up if the first thing you do is open the box, pull out the manual, sit in your comfortable chair and read the entire manual. How many people there? Have a good look round. There's 2 or 3, and there's nothing wrong with it at all. In fact, it's a very valid way of doing things. And I give another one. I'm going to try here. And where was the other one? Right at the back. Did that go in Lorenzo? I tell you what, I'm just going to take a break and come over here and give one there. And there's a gentleman right at the back. Right at the back. Now, we know what the majority answer is going to be here. So how many people would open the box, rip the plastic off the thing and just start playing with it? That is to be expected, isn't it, in an audience like this? And there's nothing wrong with that either. They're just different styles. But imagine if you're the kind of person that learns by doing, and you think, right, for this session that I'm preparing, I learn by doing, so I'm going to get them doing things immediately. And then it turns out that your audience are the people that want to read the manual. Or, in the case of a bunch of HR people that sometimes end up in presentations about things, maybe they want to do a quick flip chart session and reflect on things before they get on with taking some input and getting into some action. So what I'm saying is, for preferences, think about your own preference and consider that, but then think about the preference of your audience and walk in their shoes. Which reminds me of a famous quote by Jack Handy from Saturday Night Live. He said, if you're going to criticize somebody, and maybe some of you have heard this, but if you're going to criticize somebody, you should really walk a mile in their shoes first. Because then, when you do criticize them, you'll be a mile away and have their shoes. I think you'll agree that's very useful advice, isn't it? Okay, so think about preferences. Then there's practice. Now, first of all, what are we going to practice? Any ideas what we should be practicing? Like it, Andrew, you're quite right. Are you going to come down and get this very long twirl? It's a very good-looking piece of chocolate, that, the twirl, and very tasty as well. Well done, that man, Giovanni. This is what community is all about, isn't it? Passing the chocolate. Yes, you're going to get that. You're going to get some timing from it. What I'm driving at here is the thing that you've got to practice is the whole thing, okay? It's not, this is the standard, I'm going to tell you rather than ask you, the standard Geek practice is this. You've got your laptop open, you're flicking through the slides, you think, yeah, when this slide comes up, I must remember to say that. And when that slide's up, you know, I better say this. I don't want to forget that. That's standard Geek practice. And it's better than nothing, but only marginally. What you really need to do is to be practicing the whole thing out loud. Andrew's already given us one of the reasons, it's timing. Especially if you're in a multi-speaker conference, you need to occupy your slot, don't you? So you need to know how long it's going to last. What other advantage does practicing it out loud give you? Who said that? Quite right, it is. I don't know how I'm going to get it there, but I'm going to have a go. Confidence is... Oof. They're going to be severely broken. Confidence is another great reason. Let me give you a third reason on top. We'll go for 3. The words and phrases you think you're going to say, and they sound great in your head, might not sound so great when you come to do them out loud. They might be tricky. You might stumble over them. And so practicing out loud at least 2 or 3 times, and given what I said about the importance of the beginning and the ending, which part should we practice most? The beginning and the ending. And of course, the beginning is when we can tend to feel a little bit nervous. So if we practice that many times and we can almost go on autopilot, you know, when we're fumbling around and things, that's going to be so much for the better. So the what is the whole thing. The when is as soon as you possibly can. Even when you get a skeletal presentation together or a skeletal idea for a presentation, begin kind of talking it through. And then who to? Well, ideally, valued colleagues that understand what you're saying and so they can give you holistic feedback. If not that, interested family and friends. But if not that, everybody's got a voice and video recorder in their phone or their computer, haven't they? So you can practice into that. So there's really no excuse for not practicing your presentation. Then there's the participation, and participation is very important indeed. Getting people involved is key. Now, I've been asking you questions and giving you chocolate, but what other modes of participation can you think of? Bribery with chocolate is one. Certainly, Kent. This is kind of a meta example, isn't it? Somehow. What else, though? There's lots of different modes and means of participation. Carsten? Asking the audience questions, just show of hands and things like that. There's the last one in the bag for you, Carsten. I'm going to leave it there. You can get it afterwards. But don't worry, I've got another bag. Yeah, what other modes? There are so many of them. Go ahead, sir. Attention. How do you mean, sir? Okay, so gaining their attention. To be honest, sir, it's one of the weaker ones, but I'm going to give you some chocolate anyway, because this is what participation is all about. Have a crunchy. What about asking people for their experiences and their stories? And there's been a few, how many people are using Kamailio for this and that kind of thing. And if you can get people drawn in and involved in sharing their stories and making it a participative thing rather than doing something to people, you're doing it with them, then you're going to bring them along with you. Because here's the secret formula that's not really that secret. Involvement equals commitment. The more involved your audience are in what you're doing, the more committed they're going to be to the outcome. Then there's performance. And you've got to be very careful, because apathy is catching. And let me get serious for a minute here. Imagine if your boss asked you to deliver a presentation or to train some people, and it's something you're just not liking. You're not really into it. It's not your favourite thing. It might well be within your capabilities, but it's just not your thing. I would suggest you go back to your boss and say, actually, I don't think I'm the right person to do it. I'm not trying to duck out of this, but I think Mary down the road or Tom down the corridor is better, because they can be more enthusiastic about it. And I'm serious about this. We need to push back a little bit, because, when we're all on the same side and we're all wanting to do our best, then we need to recognise that maybe we're not as enthusiastic about something as somebody else. And the IASM at the end of enthusiasm stands for I am sold myself. So just consider that when you're thinking about your presentations, and don't let yourself get into a position where you're delivering something that you're not enthusiastic about. Because at the end of the day, it doesn't matter whose fault it is, it's the person at the front that looks like the monkey if they can't generate the enthusiasm or they don't know the stuff they're talking about. So very important that. And what you don't want is that. What you do want is this. That's a real life audience from when I spoke at the Lean Dus event in Düsseldorf. In fact, it was pre-lockdown, wasn't it, Marcus? Pre-lockdown with the SIPgate people. And actually, the next day, I delivered some training in SIPgate as well. But if you can get your audience enthusiastic and happy to be there, then that's a real win. Okay, then there's post-event. And here's what I think happens a lot. Not drive-by shootings, but drive-by presentations where there's no real consultation ahead. You don't talk to the people that you're going to deliver the presentation to. You come in, you deliver the presentation, and you get out. It's a drive-by. It's entirely the wrong thing. So many opportunities are missed in this. What we want to do is stamp out this drive-by kind of thing by really getting involved with our audience and with the sponsor ahead of time, getting that little agreement together. As I said, it doesn't have to be a weighty thing. It can have individual objectives, like by the end of a session, participants will know or be able to describe or whatever. The idea is that in your mind, you should be able to listen to or watch the participants delivering on those objectives. That will help frame them for you. But with that agreement, it gives you something to come back to afterwards, doesn't it? And in the immediacy of the end of the presentation, you can say, right, this is what we were trying to achieve in this presentation. Have we achieved it? And if not, do we need to have another session, or do we need to deliver this training to more people? But on the broader side, a couple of weeks later, you can go back to the department head or whoever it was and say, are we now receiving less tech support phone calls? In other words, as the greater, the company-wide, the macro level of outcome, has that been delivered as well? So the more we can do that, the better. Now, as we come to a close, I want to ask you, have you ever seen a screen like that? Or something along those lines? It doesn't have to be YouTube, could be Vimeo, BitChute, what are the other ones? Brand YouTube, Odyssey. Yeah, we won't mention that one, Randy, but I'll give you some chocolate. I'll give you some chocolate if you don't say it out loud. And I think you said something as well, so I don't know what you said. Anyway, if you've ever seen that, what does it indicate? When you see that, what's the problem? We've got a connection problem of some kind, haven't we? We don't know whether it's our Wi-Fi, whether it's the underlying network. It could even be the server at the other end trying to serve it to us. We just know there's a connection problem of some sort. And what I would submit to you is that when you come to speak to an audience, the rapport that you have with your audience is that connection. So imagine getting in front of an audience and not spending time in making the connection, establishing, maintaining and growing the rapport that you have with them. If you don't do that, it's not only going to be more difficult for you to give your information to your audience, it's actually going to be difficult for you to read things back from your audience. Whether it's the facial expression that tells you that they don't get it or they don't like it, or whether it's somebody nodding and saying, yeah, everything's really good, you need to grow that rapport. And so what I want to do now is just summarize those 7 power presenting protocols and show you what happens when you arrange them in a certain way. Because when you put the purpose, the plan and the preferences together with practicing it out loud, with thinking about the modes of participation before you ever get in front of your audience, thinking about performance. And of course, what I should have said when I was talking about performance is that's things like using your body and your voice and your articulation, your pronunciation, your power, and even your pauses to make the dramatic difference. That was a micro pause. It wasn't even a long pause, was it? But when you put all that together with doing something post-event as well, then woven through all of that is rapport. It's been there in every single one of those 7 activities. So can you imagine, given that these 5 have happened before you even take to the stage, that if you work through these protocols, you will have started establishing rapport with your audience before you ever see them. And then you have an opportunity to enhance it, to grow it, to magnify it, to amplify it during the presentation. Okay, I'm going to practice what I preach, and I've got a summary slide when I'm just going to go through the main points. But before I do that, what questions do you have? Daniel's ready with the microphone.
Everyone is speechless now. We think about our presentation. You know.
There's one just there. There's a man saying something. It may be chocolate related. I can just tell by looking at him. Oh, sorry. I'll give you some chocolate for saying that. Now, what this QR code is going to take you through is it's going to take you through if you want to talk to me about your presentation. That's where it's going to take you.
So,
Tim.
How do you stop being bored by the same presentation you've given 5 times?
Think of this phrase. It's not what's coming from you, it's what's coming through you. If you're conveying the enthusiasm that you have for something, and you do genuinely have the enthusiasm, it doesn't matter how many times you do it. I can give you an example of asterisk training. I delivered asterisk training, I couldn't tell you how many times, and I always loved it. Even though it's the same presentation, even though some things felt slightly samey, it was the outcome of it that drove it.
Yeah, how do you get yourself in that mind? That's the thing I struggle with.
Okay, yeah. Well, enthusiasm cannot be manufactured. It has to be genuinely there, doesn't it? And I know, Tim, that you're enthusiastic about many things. We saw it in your presentations earlier. But maybe if you're the sort of person that struggles with that sameness, it's just change things up a bit. A bit like when you go to a rock concert and you see a singer sing something slightly differently. Now, the flip side of that, of course, is sometimes the audience don't like it because it's not exactly what they were looking for. I'm afraid I can't give you a better answer than that.
Okay. Actually, we have now like a couple of questions here, but the catering is not going to stay that long, and we are getting into the break. So one more question, and the others, we
okay,
have
one
it,
more
Santiago.
question.
That's a question that is usually come to this mind when we talk about presentation. We always talk about slides. Your boss demands slides. When your host demands slides, the summary demands the slides. The slides will be remaining on the recording. Are they so important because your slides were pretty simple, and most of the slides here were simple. So, do we need to spend a lot of time with the slides itself?
Okay, what we need to remember is what slides are. And slides are a visual aid to your presentation. Now, if there's lots of important information that people need to take away, why not give that on a handout or a link to a PDF or whatever it might be? If it's information that you want people to reference, either during or afterwards, if it's a during you want them to reference, then give it to them actually during the presentation. But take away the emphasis from the slides in terms of the presentation, because the energy of a presentation doesn't come from the slides.
Okay.
It comes from the person giving the presentation. If you'd like to talk afterwards, I will be around. I'll just summarize if I may.
Just summarizing. Sorry, guys, but yeah.
I'll be here till the very end.
Yep.
Okay, so summary of our main points. It was the geek's ability to communicate and present well, which I think could do with being upped in order to help individual geeks achieve more. The trouble that arises if you don't do these things is that opportunities are lost, whether that is the job that you want, or the sale that you want, or even the funding that you want, or the injection of cash into your project. Whatever it might be, it relies on communicating to people that might be less technical. And so the solution is to massively improve your geek speaking, and I submit to you that those 7 power presenting protocols would do just that. So listen, it's been a pleasure talking to you about geek speaking. It's been a pleasure explaining those 7 power presenting protocols, but the biggest pleasure will come for you when you implement them and justly reap the rewards of being a geek that can speak. Thank you.
Thank you. Thank you.
Okay. Well, thank you for the introduction, Daniel. Let me first start with one simple question to the audience. Did you like my dangerous demo? Right answer. What do you think is more difficult? Building that dangerous demo or integrating it with an IMS network? Apparently, well, the dangerous demo itself was, I think, 100 lines of Lua code and directly connecting the pre-switch instance with our zip trunk, fairly straightforward. Integrating such an application into an IMS network is a far more complicated task. And that's what I'm going to talk about today and why, in that case, Kamailio is extremely useful. But let me first start with introducing myself. Well, I started my voice over IP journey quite early. I started with Asterisk, something pre 1.0. Quickly realized that that doesn't scale very well. Then I started to using the There project, and later OpenZer, Kamailio, everything. We did actually the first real fixed line deployment in Germany in 2006. It's really, really exciting. The first fixed line voice over IP based connection. And later I worked for Telefonica. Telefonica, I saw all the legacy infrastructure, all the Broadsoft, Ericsson, whatever we used. And during that time, I decided, well, I must do something better. I started to merge the OpenIMS core of Dragos into the Kamailio project because I thought Kamailio is a way better place for the OpenIMS core. And 1 year later, I actually founded my company, 2011, to build IMS-based solutions. Besides building IMS, talking about diameter and AVPs and all the crazy stuff all day long. I have 3 children, and I'm very involved in renewable energy and foresting. Not necessarily VoIP or VoLTE or IMS related. My company, by now we have a team of almost 50 employees from all kinds of areas, from Ribbon, from Telenor, Nokia, you name it. Basically, we hired all the best people we could get. And today we actually have real life networks running MNOs, MVNOs in Africa, in the Middle East, in Asia, in North America soon. So it's really getting real, the whole IMS topic. When I first started with the IMS in 2011 or 2010 to be precise, I was really focusing on the core parts, on the proxy, interrogated service, CSCF. We had a very small tasks integrated application server. But during the time, it really evolved. We added SMS and supplementary services and announcements and conferencing and all this stuff. And at some point, we noticed that, well, if you're talking to MVNOs, they need a PCRF. So we added a PCRF, which was developed in Python. We added an HSS later on. We actually had several attempts on HSS. And we've been really heavily integrating with all kinds of projects. And we've been very technology open. The key point is we are working on really building a full core, not only the IMS part, but all the application servers that come with it. HSS, PCRF, applications, SMVCC, emergency calling. Thanks to Wolfgang and his lost and held implementation, that's really, really great. Charging everything that you need. The key point is, if you're building mobile networks, is that you always want to keep this mix and match block. So, of course, we can deliver all the components. That's very easy, because that we know works. But of course, it should always be possible to add third-party applications. It should be able to add third-party components just to really make it work for each and every use case. And today, what we can do today, and I think if some people remember me being at Kamailio World several years ago, I used to have a really big bag with me where I had a 4G network, eNodeB, and today everything fits on a NUC. We take an off-the-shelf E-Node, costs 500 euros, very straightforward, very easy. But let me talk about application server, the whole topic of that. Why is this topic so important? Of course, I want to have a really network integrated application. I want to have the application that I'm providing should be really part of the natural call and the way the users are using their mobile device. And it's getting more and more important. Of course, you might say, well, in my country or the operator that I'm working with or whatever, they rely still a lot on 2G and 3G. But to be honest, that is, from an industry perspective, this is changing heavily. Because today we have IMS centralized services, and IMS centralized services is really like all the 2G, 3G network elements. They start registering towards the IMS core. They start sending out zip invites towards the IMS core. So today, really all calls that you see on a mobile network are, in fact, IMS calls. Quite a lot, not every operator, but it's getting more and more. So building your applications to work with an IMS is quite important. I would say, from my perspective, I have to say that because I'm the IMS guy. However, if you look at the most common applications, let's say Asterisk, FreeSwitch, Kamailio, whatever, then you typically see that, especially when you're coming from the open source world, and those applications have not really been prepared for mobile network use, then it really, then this doesn't really work out of the box. So what we need to do is we need to connect IMS to non-IMS applications. We need to build a bridge. We need to somehow close the gap between our, let's say, FreeSwitch Asterisk-based application and the IMS network. And that really has to work together. So what are the typical challenges that we face? And some of them are really simple. Apparently, we need to do some header manipulations because apparently we have to do some extra headers. We need to maybe pass through headers. And I will get to that a little bit more in detail in a moment. But we also need to manipulate headers to really make it in an IMS compliant way. But from a Kamailio perspective, it's straightforward. You're just doing append F, replace F. That's really basic. Has any one of you, and I'm just speculating here, has any one of you tried to use Asterisk from the Debian sources, installed it? Anyone? There's one, you might see one interesting thing when you look at Asterisk from the Debian repository, and I was quite surprised myself to find this. Actually, you see that Asterisk out of the box on Debian, the standard repository, supports AMR wideband. Great. A little bit surprised to find that, but it's in the official Debian repositories. But as usual, there's a catch. And I'm sure my friends from ZipGate can tell you a lot of stories about that, because apparently just supporting a voice codec isn't enough. On mobile networks, everything is about bandwidth efficiency. We're trying to save every bit and byte. My wife used to laugh at me when we said we can now even do bitwise efficient codecs with saving 3 bits on a byte. That makes a difference. But really what you see quite a lot in mobile networks is that you actually get some kind of comfort noise, like discontinuous DTX. And this is something that's actually not supported in Asterisk. And that becomes a huge issue. That will result in garbled voice. It will really not, you will get a lot of issues because you don't support comfort noise. Another thing is that you see is the devices are expecting a lot of RTCP reports. They want to see what's coming, what the other party received. So we need to create RTCP reports, even though maybe, let's say, the B party that we're connecting to don't send RTCP reports. They have to be there, otherwise the phone will disconnect. So there, of course, Kamailio and RTPProxy come in very handy, because RTPProxy supports creating comfort noise and translating TTX, stuff like that. And it also can create those RTCP events just to make it really work straightforward with any kind of application. And then you don't really care if your application supports AMR wideband, or even EBS. The next thing that you see is that sometimes we need to simulate missing features. And on the IMS side, on the network side, we do a lot of quality assurance. We do a lot of, we need to reserve bandwidth, stuff like that. And of course, the typical Sofia zip or pre-switch doesn't do that. So Kamailio can actually help us with this, because we can, with Kamailio, actually do something like simulating preconditioning on a Kamailio base, which really solves a lot of issues. Let me get some concrete examples. This is a typical zip and write on a mobile network. Looks a little bit strange, but for example, what you see here is that we've got a preloaded route going to our application server. The first route URI apparently is our application server, this is ourselves, so that's fine. But the second one is actually a preloaded route pointing back to our serving CSCF. And if you look at the end here, all the trailing stuff that's here, that's basically encoded. If you look at the typical service profile on an HSS, you see with this information you can actually point where in the service profile am I currently. What is the next step that I should perform as in service CSCF? What is the next application that I should trigger? If you strip out the route in URI because you don't like preloaded routes, then have fun, your application will not work. So again, this makes it very, very easy to makes it very, very handy to have a Kamailio in front of your application, because then you can actually replace such headers so your application can pass this through. Another thing, if you look at the contact, and actually if you look at the whole IMS GSMA VoLTE environment, you see actually that a lot of the stuff that is defined by the GSMA and by the 3GPP is actually also defined in some IATF RFCs. And one thing that you see is clearly, okay, we are indicating our capabilities, we are indicating that we are supporting SLCC, we are supporting all kinds of stuff, and we are even supporting video. You could say, well, what's the point? Doesn't really matter. But the key point is, if you want to do ViLTE, if you want to do video calling, this is crucial. If you don't indicate video to your other party, then actually the other phone will never show the option to enable video. And of course, maybe if you're using FreeSwitch, you want to do maybe a video conferencing on FreeSwitch, then you don't get that parameter by default. And of course, the B party or the parties in a conference will never see enable video for your call. And there's more things. Like, for example, if you do a third-party registration, typical use case, my phone attaches to the network, then the IMS actually can send out a registration to your application server. The challenge here is that the registration cannot be authenticated because the serving CSCF doesn't have the information about that. And you really need to do rec info We have a module for that in Kamailio, which makes it quite easy. And you need to subscribe for the status of the registrations, because otherwise you would never know if the device is online, offline, if the status of the device has changed. And this is something that's very different to all the usual ZIP registrations out there, because basically what you see is there are more indicators for pushing information about the state of the device. I mentioned previously the PCRF and the policy and charging rules function. The 3GPP guys really like acronyms. But the PCRF actually can indicate to the proxy CSCF, to the IMS network, that a device has become unavailable because it knows about the network status. As soon as you disconnect from the network without doing a proper deregistration, you actually would see a publish going out from the proxy CSCF to the serving CSCF. And if your application has subscribed for the rec info, your application will also get this information. You would likely not see a third-party registration for this case, but you would get a notify. And of course, you could then, if you want to utilize this, then you could actually use Kamailio as an application server to really do the full authentication using the UART module, for example, or do anything else what you want. And for example, everybody, like I've seen a lot of attempts and a lot of approaches for integrating Teams with Kamailio and several other projects. And I think, of course, yes, wow, great, you can make phone calls to Teams. But that's only one part of the equation, because actually what I really want to achieve is that I see on Teams if I'm using my mobile phone. And not because I'm using my Teams client, but because I'm just using my mobile phone. And of course, in this case, I can simply use Kamailio to trigger an according API call towards Teams just to change my online status. But there are also some other applications which are not necessarily voice related. And does anybody know some non-voice applications on a mobile network? What? No, much more simpler. SMS, for example. Or, for example, USSD. Has anybody of you using or seen the SMS ops module I wrote several years ago for the Kamailio project? Yeah, I hope nobody is using it, because actually it only provides a subset of the features that actually an SMS does provide. But what's actually more interesting is actually implementing. So SMS, we need to come up with a better solution. And the good thing is, if you look at SS7 signaling, SS7 is even worse than 3GPP specs, is that actually the payload that you see coming from a VoLTE handset, you can directly translate into SS7. But USSD is also quite interesting, because USSD from a call flow perspective is very much like the data channel discussion we had this morning, for example. Because in essence, you're actually creating a session, you're creating a call with the B party. But this time, instead of transferring voice, you're actually just transferring data. You see here, for example, I dial *135, I got a 200K, back. Then I got an info message in dial where I get a phrase, please enter your PIN, something like that. You can build anything based on USSD. And the most common use case for this is typically to do some prepaid chop-ups. But you could also build all kinds of other interactive services. For example, I could use USSD to configure my dangerous demo if I wanted to. There are tons of things that you actually can do with USSD. And again, it's actually not that complicated with Kamailio to build something like that. Because recently, I think last year, I added a function to the dialog module to actually send a request within a dialog. So actually, I can use Kamailio's dialog module to accept that session, to really track the session, and then really sending in dialog info messages. And then I can say, okay, I received another info message where I inserted my pin 4711, get a 200K back, and then I send a byte again, if it's an L volume, indicating the text that should be displayed to the device. And everything you can do actually with plain Kamailio content. You can use the dialog request info method, which is explicitly good, usable for that, or you can use set body for the byte message. Really straightforward, and that gets me to a rather nice small demo. Hopefully, yeah. So you see my standard dialer. I dial 135 hash on my call. Thank you, I'm a hero. But it can also really be some interactive services. You can ask things, what is your favorite network equipment vendor? What is your favorite network element? And if you get it right, thank you. That was a great success. Yeah. I didn't watch the time, to be honest, but I think I'm... Whoops. Good.
Time for good question. Yeah, still a few minutes. That with the USSID, it's pretty interesting. I'll have to look a bit at questions now with the application server in the mobile network space. Anything that you think, I mean, more like it's pretty interactive, but my question was always about this, is quite some minimalistic interface, so you can't really provide a lot of information on this USSID. It's more like enabling or disabling some feature.
Well, of course, what I could do is I could, of course, extend the input parameters. I could say, what you see in prepaid chart. Basically, you get a scratch card, you get a code, and then you basically dial star 135. And then you could basically do an API call just to execute something with that code. Or, for example, I could use it to retrieve my current credit for a prepaid customer.
Yeah.
Also quite handy. And it's really for, I would always say, for kind of small services, really like, let's say I want to configure a certain service, I want to say, okay, disable, kill all my VoLTE, then I could actually build an USSD for that, or could build any kind of really simple basic service. It's really for...
Yeah, it's nice and flexible for this text interaction, but my question would have been like, because with Kamailio, at the end, you can return even like binary data. Could you also like push something more like audio or even a picture? It is now with this protocol? That was about just curiosity. Text. Because yeah, as you said, you send a SIPp info. In the info, you could put eventually base 64, and so now it's text. That.
But for example, what I could do, I could enter my USSD code, and then I could actually trigger a pre-switch to create a call if I want to. Okay.
And call you back.
Exactly, because of course with Kamailio I have all the capabilities to really interact with them.
Okay, yeah. Or send a web link. Yeah, that could be.
Yeah, for example.
Okay. Yeah. And it was more like it's just text at this moment, or also allows extension towards something more, I don't know, visual, like image, or more auditive, like audio. But it's.
I think this is actually where data channel really becomes interesting. Because there You can actually use the data channel for interactive services while having a call setup, for example, stuff like that. But
Okay, so apparently there's a question back from Valentin. It's coming.
Thank you. Just one question. When we talk about SIPp application servers, yeah, are these self-made software or are there some open source basis for this?
Well, okay, of course, all the application servers that we provide, for example, are based on Kamailio research. But we, of course, integrated the IMS with all kinds of commercial application servers because apparently we don't do mission-critical services, but you could provide mission-critical services on an IMS, so we need to integrate a third-party application server. That's a whole point of mix and match to really select the application server that fit your particular purpose. Yeah.
Yeah, here. For the first time I came into Kamailio World, we started to talk about back-to-back user agent.
Exactly.
I don't know if you can disclaim or you can say how did you do the back-to-back user agent for Mierla application server? If you can disclaim it, based on Kamailio or something else, or just
based on something else. As a matter of fact, I'm not sure I'm allowed to say this here, but it's actually built on top of OpenZips.
Daniel, where we are going to have a back-to-back user agent in Kamailio.
There are some parts of it there, but not completely. It's waiting for your contribution. Any other question? No? Then thank you. Thank you, Carsten, so much for this presentation. Okay, so where is my phone? Oh, it's here. So yeah, for this year edition to close the event, actually, I decided to go again for KEMI because we didn't have the event for like 3 years in a row. So this would be the 4th edition after the last one. And a lot of things have happened in the world of scripting for Kamailio for building the SIPp routing logic. And I could see more and more adoption of these scripting languages. And I wanted to pinpoint a couple of, let's say, maybe not so obvious aspects that you should think about, and some of them even use from this perspective if you are more familiar with the native scripting language. So who is very, very beginner on the relation with this KEMI concept in Kamailio? So it's practically a framework that allows you to build the SIPp routing logic in other language than our native scripting language. So you can build it in Lua, in Python, in JavaScript, in this Squirrel language, which is similar to Lua, but minimal, and then variants of Python 2.3, of course, we support them. It's now more than 5 years old, and as a matter of fact, because I get it as a question many times, today or nowadays, typically it's like 50% of deployments that I'm doing with native scripting, and usually would be Lua, but sometimes it's even Python or JavaScript. because I tend to ask the customer what is their favorite language. If the team at the customer has some preferred, some knowledge there, they might go for one of the scripting languages instead of the native scripting language. In terms of evolution, yeah, all will stay in place. The native scripting language is not gonna disappear. I will show you later because should reveal what's the relation in the C code and make you understand that they are really very integrated, and that was the goal, to make it pretty effortless to add new feature and expose it to the two words, native scripting language and the KEMI framework. So of course, what would be the benefits when you use this external interpreters? First would be documentation and knowledge out there, you know, Python tutorials, Lua tutorials, JavaScript developers exist there, maybe more than what will take time to learn a new scripting languages with maybe weird syntax, routing blocks, and let's say some strange design decision like interpreting negative values as false in if condition. And then of course you have more data types, operators, functions, external libraries that you can use from the wild web, for example. And also debugging tools could be also useful in many cases, ability to build testing units for the script itself, for the routing logic. Also editors sometimes, they are more handy, more specialized for a scripting language that could make your life easier. And then of course, even in scalability, sometimes you can leverage what comes there, of course, with a little bit of careness there, because yeah, Kamailio is a multi-process and you have to be careful not to conflict with our concept with private memory and shared memory that we use in Kamailio. And one of the major benefits would be also ability to change the Lua, the Python routing script, and then just trigger a reload via RPC command with no need to restart the Kamailio. So probably this is, if you work with native scripting language and with KEMI, meanwhile, this is one of the obvious relations between the two. So with the native scripting language, we could define our keywords, our special blocks, and associate them with some processing like request route. When we receive a SIPp request from the network, it's executed. We implement the interpreter from scratch, so we decided that's fine. But then when it comes to Lua Python, we are not the developers. I don't know if I ever met the main developers from Lua and Python. Some of them are in Brazil, some of the others, Python, I think, like Europe or US. And we don't control, we don't take any decision on how that was designed or is going to be implemented. What are the keywords for those languages? So practically, it's about defining a function name that we are going to execute, and you can change it via module via core parameters, but by default we have this mapping request route. It's executed when we have a request received from the network, and in the Lua or Python or JavaScript there should be a function or a method depending on the language, KSR request route. And again, you can change this function name if you want to be different. And then we have the reply route in Kamailio language that it's executed when we have SIPp responses from the network. Then is the mapping over KSR reply route. On-send route, it's another block, and then it's KSR on-send route. So KSR comes from like Kamailio SIPp routing, and it's a prefix for this function, and you will notice is also the main object that we expose to these KEMI languages. For those TM, transaction management related blocks like branch route, on reply route, failure route, there is no default mapping, because actually you can specify the function name that you write in Python in Lua via parameter to this KSR TM, T on branch, T on reply, T on failure, which are exposed by Kamailio to that language. So yeah, I want to execute a branch route equivalent callback. I write my Lua function there, and I give the name of that function, to this case RTM Tion branch, and that's it. We have also event route, which are specific per modules or some other components executed not only related to the SIPp traffic. Usually you'll find module parameters on these modules that execute event routes, like the example here with the AV API. There's an event callback, and then you specify the name of the function that you are going to write in your Lua script or JavaScript file. Sometimes, because the modules, the component execute more than one event route, could be different style of module parameter, like AVCB, MSG for the equivalent of this SIPp trace when a message was received in the context of the SIPp trace. And here it's an example how this evap function is just writing a long message and returning one. A simple example to see, but again, if I change in my Lua script this as a name for the function, I will just have to update there, and that's it. It's my choice for this example. What might not be that obvious, but somehow should be expected to happen. Remember this evaluation of the return code that we have in the native scripting language. It was a decision a long time ago, like 2001, 2002, and it propagated over the years. So in this logical expression, because our function exposed by the modules or the code, they return always a number, an integer number. If that value is negative in this logical expression, like while if, then it's considered to be a false. So the else branch is executed of the if, for example. If it's greater than 0, will be a true. So this first branch of the if it's executed. And if it's 0, actually it's similar to an exit, like stop execution of the config file at that line and go and process the next SIPp message from the network. So what we have in Kamailio config, it's a lot like if and the function name trelay, outcheck, or other function name here. And if the function returns true, practically the actions will be executed. If this function returns false, but look at the evaluation based on the value. So when it's positive, it's like true, will get executed. If it's the code, it's negative, then will be false and jumps over it. Nothing from the if will be executed. Now with the other interpreters, of course, we have to follow their decision, and the standard there is that only 0, it's a false. When you evaluate everything, it's true. So practically you have to do explicit comparison. When we expose this KSR mode like TM, T-relay, for example, if it's greater than 0, means it was successful, the message was sent out. If it's negative, maybe it was some memory error and something like that. So you'll have to do explicit checking with the value. And of course, if it's returning 0, you have to execute the exit yourself. I'll come back to the exit that could be there yourself. As a matter of fact, I mentioned it yesterday, with 5.7, we have a new core parameter where you can turn the native config scripting language to have the same behavior like the standard. By default, it's still the old one that we have for the last 20 years. But as we try to evolve, and maybe next time will be a 6.0 release, we might switch to this standard, because for the newer generation, this sounds a bit strange, looks strange at least from this point of view. So this is something that you have to be aware of, and when you translate from native to KEMI, for example. So yeah, the exit. So exit, it's used quite a lot in the default config file, and it's an important, let's say, directive of our native scripting language, because you tell the interpreter, okay, I finished processing this message, stop here for this message, go and process the next one from the socket or whatever what was the worker, like a timer or whatsoever. And in some of the scripting languages, using their native exit, because in Lua, for example, there is an exit. If you call exit the one from the Lua in your Lua script, practically you stop Kamailio. Because Kamailio is the interpreter, and the exit is like system exit, stop the application. So don't do that, because then practically for each request that ends up in an exit, then Kamailio shut down, and you have to start it maybe automatically, but probably it's not a good experience. Usually exit is after T-relay, so the invite likely it's out, but there is no Kamailio to handle the responses or so, and you don't want to shut down on every message. So then you might notice that with some modules, because it's a special submodule, KSR X, so X we don't have a module. You could notice that we have this style with KSR module name, function name, that is kind of object-oriented. X, there is no Kamailio X module. We try to put here extension specific for the interpreter, and usually it's about this exit. And in Lua, we have this KSR X exit that you will have to use in your Lua script to stop the execution of that script for that message. And Kamailio will rerun the same script, but for the next message. It's not stopping the interpreter, it's not stopping itself. The alternative will be to propagate return codes. So you write your own method there, and some condition you return a value, and you check what was returned when you execute your own function, and you can go out. Because if you do return from one of these top routes or top mapped functions, KSR request route, if you do a return, practically you return back to Kamailio in the KEMI framework, and we'll go and handle the next SIPp message. So for Python, this is an option, but actually in Python you can use the exit because it's raising exception, which Kamailio can catch internally. But I give it as an example that you could also leverage these return codes in these scripting languages to go back to the, let's say, root function to be executed for request. And if you do a return from there, it goes to the KEMI framework and continues with the next SIPp message. Oops, sorry. So here it's more or less like a comparison one-to-one, like a direct translation from what we have in the native scripting language and what's in Lua. So we have, again, here has to tag, but then we have the approach with the KSR module name and the function. Here we just check if it's false, so has to tag return it negative, which means there is no to tag in the SIPp request. Then we go back because this is the, it's more or less from the default config file with the comments removed to be a bit smaller and fit in the slide. But it's something like if we don't have a to tag, that means it's an initial request. It's not a request within dialog and goes back to the request route. And practically, if you just translate, you have your own config and you want to translate it, it's pretty much very simple in terms of functions exported by modules, because you have like from tm tcheck trans, it's KSR tm tcheck trans. Or if you want to set a flag, we have it from the core, and here we have just set flag. Here we have KSR set flag. Here it's a define. In Lua, you can make it a constant, or you can use a function that returns Kamailio defines in the KEMI script. We have that feature, just to mention it. But then with the exit, you see we have exit here. In Lua is the KSR exit. This is another function in the Lua script. This would be like another sub-route block that we have. So this is mapped over the default config file with the names of the route blocks. So translation is really not complex. But then, of course, what you can get, import your own external libraries from Lua and use them, like maybe an HTTP client with more flexibility on setting headers and so on to do HTTP query to external systems, or other kind of libraries that you want to use, and they are available in the Lua world or in the Python world, and not possible only with Kamailio native scripting language. Reloading, so it's practically you change the Lua script, the Python script, and then you will have to execute an RPC command, which is specific for the module that implements the KEMI interpreter. Usually it's the name of the module, like app Lua, app Python 3, app JSDT, this is the one for JavaScript, .reload, and then if it's all okay, you just get a result without any error inside it. So a matter of the scripting language that you use, there is an RPC command to read again the content of that Lua Python file, somehow compile it for the first time, and then execute it from that moment on for all the new traffic. All the traffic is still with the variant of the file when it was first received. Other RPC function that could be useful, and the example it's with Lua, but should be on the other KEMI modules as well. It's listing available functions, because they come available automatically when you load a module like TM, like dispatcher. But if you want to look, and they give you also some information about their prototype, so it's going to return an integer. It's coming from the presence module. This is the name of the function, and expects 3 parameters. First string, second string, the third one will be integer. So when it's returning integer, the rule that you have to apply is the one with less than 0, greater than 0, or this equals 0 for exit. We also allow returning bool for some of the function, and then you have to just interpret it as being boolean in that language, because for some of this core function that we have in our native scripting language as keywords, it's easier to just expose it as a bool, because you have a simple condition in the KEMI script. So what are other things that are a little bit maybe not that obvious, not in the front page of the website? We have this check your config file with Kamailio interpreter, -c if you remember. It's still possible to have something similar, for example, with Lua, with the one that I work. So you update or you create this Lua script, and then you want to see if you have a typo or you have some unclosed codes or whatsoever. So there are 2 options that you should use here. First, it's the ability to generate a Lua check resource file. So there is a Python script that goes over code of Kamailio and generates a special file, and then you can use that as a parameter to Lua check, and then you give your Kamailio Lua script file, and you can get this kind of errors. So when it's something not exposed, then we'll not find it, and we'll say why is not found. Actually, here it's a typo. It should be is cancelled, but I put here a typo, and then is not finding it. It would be, if you correct it, then you run it again, and should not be any error. The warnings actually will be because this root functions is reporting, okay, you define it, but they are not executed. But actually, they are executed from inside Kamailio. So this is okay. If you get this event route function and core route block function with the warning, that's okay. And then Lua compiler, it's also useful, especially for the Lua language itself. So like having an forgetting to put the end of the quotes for a string will be from this Lua-C, the Lua compiler, that it's useful. So you can have the same kind of experience, like check before you trigger a reload with these tools. Other, let's say, tricks or suggestions that I want to highlight here, because we define it our language, we could choose our keywords, URI, from URI to URI, some special kind of value for protocol, for address family. We cannot easily push keywords into another language because the keywords are typically built during compilation and you cannot really push it as a runtime. So for this situation, we expose a lot of functions to give you similar experience from the core. So you have this like KSR is myself with 2 URI, which will be the equivalent of this condition, or checking for method types, or checking for protocol, like it is TLS WebSocket or WebSocket secure, also for the address family. So the core exposed to KEMI more than it is in the native scripting language as list of function, because in our native scripting language actually we have keywords. But this is one of the aspects that you have to take in consideration when migrating. Then what will be quite important to look at will be this KEMIX module, which is not for use in the native scripting language, is for using it in the KEMI scripts as alternative to pseudo variables, because in our scripting language we have our special variables, and because you can also have a function to work with variable names, but it's recommended to work with this dedicated function if they exist, because they go around or they skip parsing the parameter to see what's the variable, see what's the function behind the variable. So it's working directly to give you the value of the variable and no need to parse the name of the variable that could be given as a parameter to some other function. So look at this module because it's very useful and I would suggest to use it. Some example here. So if you prefer to work with this kind of values that we have in our config file, and from KEMI you have this generic function ksrpv pseudo variable get, give me the value of the request URI username. But then there is from this KEMIX module an dedicated function. So use the dedicated functions instead of this generic pv get with the name of the variable. You can still use that, it's fine, it's just, it's better in my opinion, you avoid some extra work in the C code that is done to get the same result after all. Then in the C code, a little bit more in the low level implementation, because C is compile time language, so it's you build binary and you don't know when you build Kamailio what's going to be the list of the modules loaded. So internally these interpreters created a static mapping table with some simple function that then, based on the modules that are loaded, will do this association. So the first function, which is statically defined, will be associated, I don't know, with trelay, the next one with auth check, the next one with ds select destination, depending on how the modules are loaded. Because we can expose to Lua only these static functions that were defined, but having this table with like an index association, then we have no real penalties, because from the Lua, for example, we get the function executed like this one, and inside will be execute the function at the position in the array. So it's just an extra array indexing between the Lua script and the Kamailio KEMI framework to make it dynamic, so you can load whatever module. So if you change the order of the module, practically the mapping will be different, but the behavior will be the same. So it's really one-to-one and array index-based mapping that will make it fast and no visible penalty in terms of performance. And then in the code, just to show you that's quite tight relation between the function we expose. So in the native scripting language, you have this from SIPp utils module, isTel number, where you can give a parameter that could also include variables. So some static string plus 30 and a variable x that you will have to set. When this is executed by native scripting language, it's going to call this in the C code, if you look, so it's copy and paste, which here it's actually evaluating this parameter, which will see, okay, it's a variable. Let me call the function behind the variable to get the value, concatenate with that prefix. And in this local variable will be the value. So if inside var x it's like 1, 1, the parameter will be evaluated and this variable will be set to plus 50, 1, 1. And then it's calling actually with this plus 50, 1, 1 value through the variable where we store it, the KEMI function. Because from the KEMI function, we get directly the string. Because in the KEMI, you will call something like this, KSR SIPp utils isTel number, concatenation of two strings, plus 50, and then I made this function call, KSR pvx, get me the value of the variable x. And it's coming directly with the final value, plus 50, 1, 1. And it's calling this one. So practically, the native interpreters calls internally a wrapper around KEMI. Because Lua takes care of building the final value of the parameter. So it's a really tight relation, and it's not complex. Usually, you build a KEMI function now, and then you make the wrapper to evaluate the variables that could be passed as a parameter. And other tips that you can do with Kamailio is like cross execution. So sometimes maybe you want to have a route block where you remove headers and so on with, let's say, this kind of Kamailio pre-compilation of the parameters. There is no problem to have that in Kamailio CFG, even if it's going to execute Lua or Python as main routing block via KEMI. So in KEMI, you have this function, ksr.route, and the name of the route block. And this one, you can still have it in your Kamailio CFG. So from KEMI script, you can execute parts of config that are written in the native scripting language. And obviously, you can do the other way around. You can keep your main logic as a native scripting language, and then you have this kind of inline execution, Lua run, where you give the name of the function you write in a Lua script. And in this, even if it's not like the engine is not KEMI, the engine is still the native interpreter, you still have available here in the Lua script all the KSR object and library functions available. And sometimes you can make this old config a little bit more dynamic. Like you say, okay, at the beginning, at the end of some blocks, I execute some functions, which could be initially just some logs or just return. And then you can extend it and then do reload, because you can change the Lua script, do reload of the Lua script, and will be visible here on these blocks, just as an example of how you can make this config more dynamic. So yeah, these are the performances, just to avoid the question at the end eventually. It's still, I haven't spent time to do a recent performance test for it, but the numbers were good from the beginning, so I haven't noticed any penalty lately. Giving you the link if you want to reproduce it yourself. Actually, sometimes the Lua is faster as average, because Lua does also some compilation in memory. So depending on the config, you could get a very good performance. But also Python is really fast with the latest version, at least Debian stable. you don't see any relevant difference between the two. Some summary, but again, they are from the web. You can read more about to see how the tests were done and the results, as I don't want to spend not being anything recent about that. So that would be about KEMI, but you know, as with every event, sometimes you are prepared with a backup presentation in case of speaker not making it, like Charles happened to miss the flight this time, but we needed more time for dangerous demo, so I was happy that I don't have to do that presentation. But I want just to highlight this tool that you might not be familiar with, which I wrote, SIPp, which tries to be like an alternative to SIPsec, going a little bit into SIPp because it has the ability to use templates for fields. Even got quite good stars there, 178. I didn't notice that before. But yeah, one of the benefits or the features would be ability to do a WebSocket connection from the terminal, which SIPsec and other tools don't do it. So if you want to test if registration over WebSocket works without initiating a JavaScript application in the browser, this could be handy and can do some scenarios like create a call, wait, and then send the buy. You can also do like a registration, wait, and do unregistration after 10 seconds. So it's not only like one shot, so it goes a little bit more into some scenarios. It's Golang, so you can use it in Windows, in Linux, in macOS. And hopefully, yeah, maybe some of you will start contributing it. Some example here, so it has more flexibility in specifying the target address, just IP port, or CPURI format, or Kamailio socket-like address. Could be easier for some scenarios. Creating this kind of call from signaling point of view, no audio support, sending messages from the terminal, setting additional headers. You can set it many times. So here we had two headers, two special headers. So it's quite flexible. The main reason for me was the ability to have a better TLS support because SIPsec was a little bit outdated on that. But even more important was the ability to have a tool that can do WebSocket connection from the terminal. So that would be, before closing, I want to highlight the next two events that I'm going to. And as I could notice here, it was a high interest in the 5G, future 6G eventually. The partner from Focus Institute, which is not here, it's in Charlottenburg, still Berlin, but another district. They have their own event, Fuseco Forum, in September, mid of September. And if you really are into just mobile world and you know this future 5 or 5-6G, that could be something to look at. They're only like research topics, what's going to be in future, while here was more like what exists at this moment. And of course, with the friends at Free Switch, ClueCon will be there in mid of August. Last, thanks this time for the sponsors that made it possible to resume after the pandemic and have this in-person event. And I'm really happy that so many of you returned it and many new came and we were able to work with a full event this time. And yeah, that will be. Thank you.
I'd like to say thank you to Daniel for not giving up and making sure that Kamailio World has happened this year. I had forgotten how valuable this is to all of us. It's not about the technology so much as about the people. And just being here with all of you is absolutely great. So thank you,
Daniel,
for that. And And the rest of the team and the PassCon video guys as well. Thank you. Brilliant.
Yeah,
as
really,
always.
thank you guys. And questions, if you have questions.
Hello.
Okay.
Thank you. And question is regarding this SIPp tool. Is it possible to specify source address for?
Yeah, for UDP, for sure, you can
And-
specify the socket, and also for TCP, if I'm not wrong, I
Different
made it, but
ports.
sometimes it's a matter of the kernel, but you should be able to specify local socket. The latest addition, which are not in the release, is in the developer branch. You can also do simulate like flooding many traffic, and you can even reevaluate the template, so another call ID and so on, which I think it was not in the list of the feature because it was not yet released, but you can get it from the, probably I'll do a release in a few weeks. There are many features there.
With the KEMI interface, how should I handle variables, like transaction variables, things like that?
There is this generic function, KSR PV get, and you can use AVP, XAVP, which are the transaction variables. So that, but then you have also, I think it's from AVP ops module or from PV module, there are dedicated function like XAVP get. So that would be ksr.pvx, because PV module has the ID in KEMI-PVX dot AVP XAVP underscore get and the name of the variable. Or you have the variant with this standard where you give $AVP.
Should I avoid using Lua native variables, things like that?
No, you should use it because then Lua is faster for doing local operation. If you need to do concatenation of strings in Lua or some operation, just call with the final value the function from Kamailio, because for sure it makes no sense to pass like setting a value in a Kamailio variable, increment it, and then pass it to a function makes no sense. Compute the value in Lua in Python and then give the final value to the KEMI function.
Thanks.
Thank you. Okay, so because you resisted, well, I still have like 3. You said, David said not to finish with the questions, right? So I'm finishing with something that you remember. I left with a gift from there. So yeah, I have here 3, one set, the last one from Snom, some deck phone with SIPp support, and 2 Kamailio books. Okay, who wants to extract? So if we extract a name and it's not here, sorry guys, we don't ship it, we'll extract another one.
Mine.
So the first is the Snom.
Greg James.
Not here, next one.
Gary Jacobson.
Oi, okay. It's worth waiting, yeah?
Thank you.
And the last 2, okay, let's go to Maureen, not to have Giovanni extracting himself.
Andrei something.
Andrei Zilenko. Ah, he left. Okay, next one. Oh, no, she has the auto. She has one at home. Jan Lawrence, oh, the video guy. Okay, and extract the next one because I have 2 copies since I'm at you.
Volker, Danneberg.
Volker, Danneberg. Okay, good. So I think the video guys were a little bit lucky. You're welcome. And Jan, stand up because he was the main guy with the video actually. You're welcome. Okay, guys, thank you so much. And yeah, we hope for the next edition next year, maybe a little bit earlier in like end of April, May timeframe. But really, I'm glad that you came and really happy with the outcome of the event.